So let's dive right into JavaScript, into its core syntax and some core features which you'll need in any JavaScript program you're going to write. Specifically, in this course module, we'll have a look at the core syntax, so how you write valid JavaScript code. We'll explore variables and understand what we use them for, how we create them, how we use them in our program, and with which kind of data we can work in our program. We'll have a look at operators, so how we can actually run calculations and execute some code by combining values and by doing something useful. And we'll also explore and use functions, an important language construct, which you'll find in actually pretty much any programming language you can work with, and therefore it's also part of JavaScript. And here we'll have a look at what functions are, why we use them, and how we use them. And we'll do all of that, all these things, in the context of a basic application we're working on, where we can also see something on the screen and where we see these things come together in a real-life example. Now for that, we need a basic website where we can use JavaScript. And I'm using a website here, and I'm not running JavaScript on the server, as I also mentioned in the first course module, because I find it more interesting to learn JavaScript if you can see something visual on the screen. And a website is something visual, which is why we'll use that. Now for that, for this basic website, attached you'll find a starting project, a starting code, which you should download and extract and then pull into a folder which you then open with your favorite IDE or code editor. In my case, I'm using Visual Studio Code, which is the tool I explained in the first course module, set up as explained there. So I'm just using that setup and the tool I explained in the first course module. So open the extracted attachment with that tool here by going to File, Open, and you should then find a folder structure that looks like this. Now, one important note, the .VS Code folder might not be there in your setup. This is just a folder created by my IDE, by Visual Studio Code, to manage some settings. In this case, the zoom level, which I set so that you can clearly see all the code I write. So that's not something you have typically. And git ignore, I have this because I'm also working with Git, which is a source control management system. And you don't need to use that. You don't even need to know what that is to follow along. It has nothing to do with JavaScript. After this lecture, you find a basic introduction to it, but you can also skip this for now and come back to it later. It's not required, not directly related to JavaScript. So what you should have in here is this index.html file with a basic HTML skeleton, nothing too fancy in there. I'm pulling in some fonts, linking to the style sheet, which you find in the assets folder in the style subfolder. And then we have this basic skeleton down there. And in the script section, you find one starting script. You can look into it, and there's a bunch of code which probably won't tell you much, which I provide to you because this script actually includes some features which we don't really know yet, which we also won't fully understand by the end of this module, which is why I provided instead of writing it together with you, but which we'll of course be able to understand later in the course. But we need that to get something out on the screen and see something on the screen and not just have a boring application where nothing changes. Hence, I provide this to you. For the moment, you can just ignore this, take it for granted, and this will all make sense a bit more by the end of this module, and ultimately way more later down into the course. But of course, we'll learn more than just that. This is just some starting script which we need. So that's what we got. Now you can double click that file here, not in the IDE though, but instead in your normal Windows Explorer or Mac Finder. So there, simply double click that index.html file, and it will open up a brand new window in the browser, which should actually yield this interface. Now, this is a basic calculator, which will work a bit different than most calculators you're used to, but nonetheless, which we'll work on throughout this module. Now, for the moment, you can type and hit what enter you want. Nothing happens here because we'll write this logic together. And by writing this logic, or whilst writing it, we'll dive into the basic JavaScript features. So that is what will build this calculator here. And now to build it, let's start writing some JavaScript code, because we need some logic that runs here with that page being loaded in the background, so to say, to interact when the user presses one of the buttons and to update the result, which we see down there, and so on. And that's what we need JavaScript for, because with just HTML and CSS, we can't add this in the browser dynamic logic. As you learned in the first course module, you need JavaScript for dynamic features or for dynamic actions like this, and that's exactly what we'll dive into in this module, therefore. So we want to write some script code, and as I mentioned already, you got the vendor.js file, which you could name however you want. I just named it like this to make it clear that I provide this to you and you don't really need to care about it. So we could add our code in that file, but actually we won't. And instead I'll create a separate brand new file next to it, which I'll name app.js. Now you can also name this file however you want. I'll name it app.js because it will drive our simple front-end browser-based application we're building here, but you could name it my-script.js or just script.js or whatever you want. The only thing that matters here is the file extension, which should of course be .js because it will hold JavaScript code. Now that's the script file we'll work on, and that's the file where we will add our calculator logic. Now to get started and see that this works, let's start very simple and simply add in an alert where we say this works. Now, you might not fully understand what's happening here, what this alert thing means, what these parentheses mean, what these single quotes here mean, and we'll explore all of that throughout this module, but just enter this for the moment and then go back to your page and reload. And what you'll see is that nothing happens. Well, the reason for that is that, of course, I added my script file here, but the default behavior of the browser is not to scan all subfolders next to my HTML file, which I loaded, for scripts which it could execute. That would be a horrible default behavior, because it would mean that we can't control when which of our scripts runs, and we want to control that. So of course it's good that the browser doesn't load and execute our script by default. But how can we tell the browser that it should load and execute that script? There are a couple of ways of importing JavaScript. Now, the first way of importing it is to go to the HTML file, and in there, like here, in the head section, let's say, you can add a script opening and closing tag, and you can add JavaScript between those script tags. So we could write alert, this works, between script tags in here. So the alert function, just as I used it here in app.js, but not in app.js, but between the script tags here. If we do that and I reload this page, you see, before the page loads, I already see that alert indeed, and I can click OK and confirm this, and now the rest of the page loads. Now that's one way of doing it. Now you can, of course, throw in some script code here into your HTML file, but the downside with that is that the longer your script gets, the longer this HTML file gets. And this is not necessarily a technical issue, but one issue it might be is that for you it gets harder to manage your website. If all your script and all your HTML is in one file, then this file gets very big. And if you then ever need to change something in there, be that JavaScript or be that HTML, you need to scroll through all the content here and find the part you want to change. So putting your scripts in there is typically not the best idea unless it's a very, very, very short script. Instead, you typically want to import your script. And therefore, you add a source attribute, src, to the script tags, and then between double quotes, typically, single quotes or no quotes at all would also work to some extent, but typically use double quotes, you point at the location of your script file. So in my case here, I point at the assets folder by adding assets, then a slash to kind of go into that folder or to tell the browser to look into that folder. And then there we want to go into the scripts folder, right, which is a folder we have in there, and then go into that folder and then load the app.js file. That's what we want to tell the browser. It should go in there and load the app.js file. Now important, you still need a closing script tag here. You must not have a self-closing script tag like you have it for the link. That's not supported for script tags. You must have an opening and closing separate script tag. And now with that, indeed, you should see that when I reload the page again, we see just this works from this file. So if I go back and I reload this page, indeed, we see this works. And if I confirm this, the rest of the page loads. So that's how we can import a script. One problem we're facing here is that this blocks the rendering of the page until the script is done. And in the case of an alert, the script is really only done when the user confirmed the alert, so when we close the alert. To make sure that the page loads first, we can do one simple thing. We can take the script, take it out of the head here, and move it to the end of the body, so that the browser has a chance of first parsing all the HTML code and finishing that rendering before it executes our script. And later I'll show you an alternative strategy to that as well, but for the moment we can do that. If I now save this and we now reload, you see first everything renders, then we can click OK, and then it finishes. Now actually the font only came in after, but that's something we can work on later. For the moment, this is better than what we had before because at least the majority of this file is now done loading before the script executes and blocks the browser from finishing this up. So that's the basic setup we'll work with. Now, we will also depend on the code I run here in the vendor.js file, and therefore you should import that as well. And you should import it before you import the app.js file, because the code we write in the app.js file will depend on the code in the vendor.js file, and the order does matter in JavaScript. So we have to import the thing we depend on before we use it. So we first import from our assets folder, scripts folder, vendor.js, and then you have your import to app.js, so that in the app.js file we can actually work with the things that are happening in here, even though we don't fully understand what's happening in there yet. So that's the finished import setup we need. Now with the importing done, we can dive into actually writing some JavaScript code. So it's time to write some JavaScript code in this app.js file. And for that, I'll first of all clear the alert code. Now, our goal is to write a very basic calculator here, where we can enter a number here and add this to the last number we entered up there. So basically a calculator where we can always work with two numbers and add a new number to the old result and so on. So that's the goal here, such a basic calculator. Now for that, we'll need a couple of important pieces that will actually be found in most JavaScript programs. For example, variables and constants. That's a core feature, not just of JavaScript, but of most programming languages. Now, what are variables and constants? In JavaScript, you define a variable like this, and I'll dive into the exact meaning here in a second. Now, what a variable is it's a data container, or data storage, you could say. In most programs you're going to write, you're going to work with some data. Be that a username entered by the user, which you then use to log the user in, or as an example of our calculator, be that our most recent result we have and the number the user just entered, which we want to add. So that would be data that we want to store because our program needs that data to work correctly. For example, in the calculator, we need the old result and the number the user just entered. So we need these two pieces of data to derive the new result. So we need these two variables to get our new third variable, the current result. So a variable is a data container which holds some data. And in JavaScript, we create a variable by using the let keyword, which you see here on the left, then a name of your choice with some naming rules in mind, which I'll dive into later, then an equal sign, and then the value you want to store in the variable. Now, with a variable created, you can also always reassign it and store a new value in there. So here I'm using the existing variable username, and I assign a new value to it. Now, I only need the let keyword, which JavaScript understands, if you introduce a variable for the first time. If you then assign a new value to it, you don't repeat that keyword. So you only need the let keyword to let JavaScript know, hey, here's a brand new variable my program will need. If you then use that variable thereafter, you do that without let. So a variable is a data container where the value can change. Doesn't have to, but often it will. Now you also have a special form of that variable, you could say. You have constants. For example, let's say you have a total amount of users in your application, which is kind of fixed. Now that's still a data container, but instead of with the let keyword, you create it with the const keyword, another keyword which is built into JavaScript, which JavaScript recognizes and understands. Now the special thing about constants created with the const keyword is that there you can't change the value. If you try to do that, you'll get an error. So there, the values must not change. Now you might wonder why you would have some values stored in a variable if that's not really variable, if it can't really change. And the answer is, sometimes in your code, you have values which never change, which you still want to store in such a data container so that you can initialize them in a central place, let's say at the beginning of your file, and then use them throughout your program. Maybe use the same constant multiple times in different places, so you will always reference the same single constant. And if you then ever, in code, when writing your code, you change that value, you change it in one place instead of 10 different places. But that will become clearer once we start writing some code, which we'll do in a second. For now, just be aware of these two different ways of creating variables with let and with const, where variables with let can be changed, with const they can't be. The general syntax is keyword, name, and then if you want to store a value right away, equal sign at the value. And also one little hint right away, you typically want to use constants as often as possible, which might sound strange at first because they're restricted in what you can do with them, right? You can't change them, but that's exactly why you want to use them as often as possible. It makes your intention very clear. If you have a value which actually never changes throughout the life cycle of your program or of the part of your code where you use it, well, then you want to make that clear so that if any other developer ever reads your code, quickly understands that this piece of data is never going to change. It simply makes your code easier to understand for others. Now, that was a lot of new and very theoretic knowledge. It will make more sense once we use it, so let's use it. Back in our calculator, we can already start thinking about data containers we might need in there. And there, one value that immediately comes to my mind when thinking about a calculator is the result. So we can create a result variable with let, so with this special let keyword, which JavaScript understands, and then give it any name you want, like result or current result. Now, regarding the name of your variable or constant, there are a couple of rules and recommendations you should keep in mind. There are certain allowed and not allowed names. So allowed is this name, for example, username, written like this. And it's a best practice to use this special naming convention, which is called camel case, which means that your name starts with a lowercase character and is only one word. So there are no blanks in there, no white space. That would actually be forbidden. But every word inside of the word, like name here in username, starts with an uppercase character to make that more readable. So that would be a variable name which is allowed. It also is a good name because it describes what's in the variable. So here we would probably store the name of a user. So that's a better name than what the user entered, because it might not be clear if what the user entered should be a username or a password. So you want to give the variable a name that describes which kind of data you're storing in there. By the way, also important, JavaScript is case sensitive. And this means that it really matters whether a character is a capital character or not. So username, written the way it's written here on the left with a lowercase u at the beginning and then the uppercase n in there, is not the same as if it were written with an uppercase u at the beginning and otherwise the same. So the casing in the names you choose really matters, and that's important to keep in mind. Now, also allowed would be a name like this. It's basically similar to the first example, but this also includes a digit because your variable names can be made up of any letters or digits. You can also use the $ special character, and your variable name can even start with it. You can use it anywhere in the variable name, but it can even start with it. Similarly, you can also use the underscore character at the beginning of your variable name or anywhere inside of it, so that's also allowed. Now, there are a couple of names which are not allowed or not recommended. For example, username like this. This is actually allowed, but it's a bad practice. You should use this camel case notation on the left with lowercase starting character, one word, and each word inside of the word starting with the uppercase character. So here, what you see there is actually another convention called snake case, which you have in some other programming languages like Python, but not in JavaScript. So whilst this technically would be a valid name, you can use an underscore here. Whilst this would be a valid name, it's not recommended. Instead, use the version on the left. Now, what's not recommended, but more importantly, not allowed, is, for example, a variable name like this. Whilst I did say that you can use any name that uses letters or digits, you must not start with a digit. So your variable name or your constant name, and everything I explain here is true for constants created with the const keyword as well, these variables and constants must not start with a digit. Now, there also are special rules when it comes to special characters. You can use $ and underscore at the beginning of your variable or anywhere in your variable, but you must not use other special characters, neither at the beginning of your variable nor anywhere else. So dashes or white space is not allowed. The underscore is allowed, as mentioned on the left, but other special characters are not allowed no matter where you plan on using them. And the last important thing you should keep in mind, in this course, you will learn about a couple of keywords, like let and const. And using these keywords as names is also not allowed, because how would JavaScript be able to find out whether you want to use the keyword here or your variable, right? It wouldn't, and therefore this is not allowed. So now that we know what's allowed and what's not allowed, let's go back to our code and write some good code. So I got the current result variable, and now we could write the variable just like this. Now, in JavaScript, you don't have to initialize this variable with a value, so you can leave it like this. So now it's an uninitialized variable. You could also say, and that's a term you will hear in other programming languages as well, this variable is now declared. The program, JavaScript, is now aware of its existence, but it's not initialized or defined yet. It has no value yet, or no value set by you. So you can leave it like this, and sometimes this is just what you need. Sometimes you have certain variables where you don't really need a starting value. For the result, however, I'd like to have one, and therefore I'll add an equal sign, and then set an initial value which could be 0 here, the number 0. And I'm using a number here because, of course, I want to use this variable in some calculations later, and add numbers, deduct numbers, and so on, and therefore having a number here with which we can do mathematical operations makes a lot of sense. Now, to conclude our first line of JavaScript code we write, let's see how we end this line. We could end it like this and just go to the next line to write the next piece of code, but you'll also often see code where we use a semicolon to finish off this line. Now, in JavaScript, using the semicolon is generally optional. I'm saying generally because there are some very rare niche cases where it's not optional, but you can avoid these cases typically, and hence you can write JavaScript code without semicolons. And you'll see certain tutorials or guides which actually recommend that you don't add a semicolon. Ultimately, it's up to you whether you want to end each line of code, and that's not just the case for variable definitions, but for any code you write basically, whether you want to end these lines with semicolons or not. I personally like to do it also because there are many other programming languages where it's mandatory to use a semicolon, and it's easier to switch to those if you're used to adding it, but you can also avoid it and just use a new line to, well, write a new expression. It's up to you, just whatever you you should then stick to it and be consistent. So I will go with semicolons, not just here, but throughout the rest of the course, but it is up to you. So we wrote our first line of code, and we're setting a variable here. And this variable, of course, doesn't do anything yet. Now, let's do something simple. Let's, for the moment, not care about what the user enters here, but let's make sure that we actually right away have a simple mathematical operation where we output the result down here in the result part of this screen. And therefore, I want to set current result to a new value, and that new value will later be the user input, but since we don't really fetch this yet, I'll use a dummy value here, let's say 10, but you can use any number you want, and add this to the current result. So let's say current result plus 10, and then store this value back in current result. So here a couple of things are happening. I'm again referring to the current result variable here on the left side of the equal sign and on the right side. And if we start on the right side, I'm using the current value stored in current result, and I'm adding a value to it. In this case, 10. I'm adding by using this plus operator. Now, operators are something we haven't heard about yet. What are operators? Operators are syntax features, or a syntax feature in JavaScript that allows us to manipulate values, you could say. And there are the typical mathematical operators you're used to. Plus, minus, then the asterisk operator, the asterisk character here to multiply two numbers, and the slash to divide two numbers. There also is a modulus operator, the percentage sign, which divides two numbers but doesn't return the result of the division, but the remainder, so the part that remains if a clean division without a decimal value as a result isn't possible. And there also is the exponentation operator, which allows you to, well, use exponentation on a number. Now, these are the mathematical operators, which you typically also know from math. There also are other operators in JavaScript, like the assignment operator, which we already used to assign a value to a variable, the equal sign. So here in this line of code, we're using two operators, the plus operator to combine two numbers. And now this combination, this operator yields the result of this mathematical operation. And we then assign this result we're getting here with the equal sign to the value on the left, or to the variable on the left. So here, current result gets overwritten with the result of this operation. And now we use current result on both sides of the equal sign, but the right side will execute first. That's something you can just keep in mind. And therefore, we'll use the old result, 0, here, add 10, and therefore we now have 10 as a total result, and then we override current result with it. So we only override it after we're done with this calculation, so that we don't try to override it with a value we depend on or anything like that. So now current result after this line was executed will store a value of 10. Now to output this, we can use one of the things I'm providing here in Vendor, and we'll learn what exactly that is in just a second. For now, we'll use this output result thing by simply writing output result here, and then adding parentheses, opening and closing, and in there you can pass in current result, just like this. Also add a comma, and thereafter two single quotes with nothing in between. Again, I'll come back to what this is and what this does in just a second. If you do that and you now reload your page, you should now see result 10 down there. That's just the result of our code which executed here. We're calculating this result, storing it here, and then what this thing here, which we're getting from the vendor file, what this does is actually, it just takes whatever we pass in here and outputs this in this part of the HTML page. And throughout the course, it will become clearer how this works. For the moment, we can just take it for granted. So we had a first basic look at a variable, at an operation, and then at this thing here, which we don't really understand. Let me come back to that operation. Here, we use two operators, but as I mentioned, there are a couple of operators available, actually more than the ones I just showed, but even with those which I did show, all these basic mathematical operators, you can do a bunch of things. And you're not limited to 2 operators per line or to 1. You can also add the asterisk here, the multiplication operator, and multiply this by 3. And JavaScript by default follows normal mathematical rules, where it will now first execute 10 times 3 and then add this to current result. You could change that order, however, by adding parentheses, just like you do it in Moth. If I add parentheses around that, now JavaScript will first add 10 to current result and then multiply the result of this with 3. And of course, we can then also divide this by 2 and subtract 1, or whatever you want. You can have any mathematical equation here, any mathematical operation here, as long as it should be where you can use parentheses to group the different mathematical calculations together if you need to do that. So now if I would run this, for example, I get a result of 14, because we have 0 plus 10 times 3 divided by 2 is 15, minus 1 is 14. So that makes sense. Now, with that out of the way, let's think a bit more about the values we're actually working with. I added a number here, but numbers are not the only values you can use in JavaScript, and actually in all other modern programming languages. Now let me also make clear what output result really does here. This does something which is called call a function, which I'll dive into later, so we can ignore this for now. In the end, it triggers some code which I defined here in vendor.js, and this code uses 2 pieces of information which I kind of forward to it. Again, we'll figure out the details of what this is and how we use it later, because we'll write our own functions then. But in the end, I push this data to this thing in Vendor. What this does is it takes these 2 pieces of information it gets and writes them into my HTML code, you could say. Because ultimately what that code does, without diving into the details, which we'll also cover later in the course because it's a bit more advanced, what this code does is it targets 2 places, 2 pieces of our HTML code, these 2 lines essentially, and overwrites the data which is hard-coded in there with dynamically derived data, well, with the data you're forwarding here. So with your result and with this empty string. That's what's happening here. So which data types are available for you to use? Well, there are numbers, which are just used, and of course, not just positive non-decimal numbers, but also negative numbers like -3, or numbers with decimal places like 22.956. And important here, numbers with decimal places, so like 22.956, are called floats or floating point numbers. Numbers without decimal places, like here 2 or -3, are called integers. Now you, of course, use numbers for any code where you need to calculate something or where you just need to work with a number. And of course, typically that's a lot of code. Whether you're having a calculator like we're writing it, or you're working with some prices or something like that, you would typically work with numbers, of course. Now, you don't just have numbers in code, however. Sometimes you also need text. Let's say you're working with the name of a user who logged in, or you want to show a message to the user. Then you're working with text, or also called strings. And it's not just called strings in JavaScript, but in other programming languages as well. So if I say a string, I mean a text type. Now, you can actually create a string by wrapping your text between single quotes, double quotes, or these backticks here, which you find on your keyboard. All 3 creates a valid string. You can use whatever you want, you just should be consistent, though the third option here, the backticks, that's kind of special. I'll come back to what's special here later. For the moment, use either single quotes or double quotes. And then again, be consistent and always use that. So that would be important for outputting results, for gathering user input, for showing messages, things like that. Now we can see both types in action here in our program. We got a number here, we got a bunch of numbers here, And this thing here, this actually is a string. It just happens to be an empty string. Now, with empty string, I mean that this is just an opening and closing single quote, and I could have used double quotes, as I mentioned, but there's nothing in between. Because this output result thing here actually is responsible for writing to two places in my web page, and for now I'm only interested in writing to this place here and output my number. I'm not interested in writing to the other place, and therefore I tell it to write nothing to that other place. Now we could actually write our log here to the other place. And that could be done by creating a new variable, let's say calculation description. And you can use any name you want here. I just try to describe what I'll store in this variable. And what I will store here is a description of the calculation we just ran. And that would be that we had 0 plus 10 in quotes times 3 divided by 2 minus 1. Now the important thing here is this is now not a mathematical equation which will be executed by JavaScript. This is treated as text, and therefore JavaScript won't even try to execute it in a mathematical way. Instead, we can now pass calculation description to this output result thing. So I'm referring to this description here. And what will now happen is that you see this text here once you reload this page. Again, this is just the text I just entered. It looks like some mathematical equation which should be executed, but since I'm not using numbers here, but I'm wrapping this in quotes, I'm telling JavaScript, this is some static text. Don't touch it. Don't try to execute it. Take it as text. I could be saying hi there in here as well. If I would do that, then we would see hi there here. But of course, I just want to, in this case, in this application, log my calculation, which I effectively have up there. And therefore, this is what I use here. If I would use current result in here, JavaScript also wouldn't try to look into this variable. Instead, it would take this as part of the string. And hence, if I now reload, it would say, well, this here. It would not give us the value which is inside of current result. Instead, it would just take this as some text which it should output. If you would want to use the value here, you would have to do something which is called string concatenation, which is you build a string from multiple substrings. So here we could say this opening bracket, the opening parentheses here, that's in a string. Then with the plus operator, we add current result, now not between quotes, but just like this, and therefore JavaScript will now go ahead and look into this variable. And then I will concatenate this string. So now again, between quotes is this string. The pluses here are also not between quotes because I don't want to treat the plus operators here as strings, but instead as normal operators. Now we used plus before with numbers. JavaScript actually can also work with plus if you're using it with strings. Then it will not try to use plus in a mathematical way. Instead, it will just combine multiple strings, so multiple text pieces, to a longer text piece. And that's what's happening here. We're combining this parentheses with the actual value that lives in current result, and then with this part here to a longer string. And actually here, you should add some white space so that in the final text which is created, you have some empty space between the plus and the value that's stored in current result. Now the output you'll get if you reload might not exactly be what you want, because it actually yields 14 here instead of 0. But if you take a closer look at your code, that makes sense, because current result is 0 here, but then we calculate a new current result. So if I then use current result here, I of course take this current result and not the one I had up here. The reason for that is simple. Your JavaScript code gets executed from top to bottom. Actually, your HTML file gets parsed from top to bottom by the browser. And if you then import some JavaScript in there, well, that file gets evaluated and executed by the browser. And the code in there also gets executed from top to bottom. And that's default JavaScript behavior. And hence, of course, if you do something in this line and then you use it in the line thereafter, you get the result from this line and not the result from the first line. It would be pretty bad if that would be the case, because then you could never do anything in your code. So to print 0 here, we would either have to do this before we execute this line, or store this initial value in another variable. And that's actually where we could use a constant. Let's say we're writing a program here where we want to initialize our current result with a default result value. And I'm naming this constant here, default result. You could pick any name you want. Now I'm using the const keyword to indicate that the value I store in here will never change. And I store 0 in here. Now we can use the default result here to initialize the variable. Yes, you can initialize a variable with the value of another variable or of another constant, and that's exactly what I'm doing here. The result of that is, if we now change current result, we can do that because that's a variable created with let. We couldn't change default result, so if I would try to do that here, and I now save this, you will actually see 0 here because our script broke, and you can see that in an even better way if you go to the developer tools here. In Chrome, which I recommend that you use, you find those in the View menu and then Developer Tools, or by using the shortcut you see there. Now, what are these developer tools? I'll have a whole module after this module where we dive deeper into them and what you can do with them. In general, that's simply a tool built into the browser, which you don't typically see or use if you're using the browser as a normal, user. But as a developer, this is a special feature built into the browser that helps us understand our code, look behind the scenes, have some insights in how our code executes, trace and fix possible errors, and also see error messages or info messages being output here. So these are the developer tools, a crucial feature which do not just exist in Chrome. Firefox and Edge also have developer tools built in. Chrome just has very good ones, and therefore that will be the browser I use in this course. But again, I'll have a whole module where we dive a bit deeper into developer tools and what we can do with them after this module. And in these tools, if you go to the console here, so to console, you should see an error, assignment to constant variable. That's a problem. Your browser complains about it because that's not allowed. So that's not allowed, but assigning to current result is allowed because that's a variable. But since I now store this default result, which I then use to initialize current result, I can also refer to this down there when I output my text or when I generate my text. We can refer to it here and here, so I'm referring to default result in 2 places of my code. I'm never changing it though, because that wouldn't be allowed. Now we introduced a constant, and you might be wondering if we're not implicitly still changing the constant with our code. Because I initialize current result with the value which is stored in my constant, and since I thereafter change current result, you could think that implicitly we also change the constant, right? Because we set those equal in this line. But it's important to understand that indeed we are not changing the constant here, because here we're copying the value that's in the constant into this brand new variable. So if we thereafter change the variable, we're changing the copy. The original constant and its value are untouched if we then change the variable. That's something important to keep in mind here or to understand. And therefore now if we reload, we see this result and we see the correct text representation of this calculation, because we're now using this correctly and we're building a text with our default value which never changes. So this shows us constants and variables in action. It shows us operators, both used with numbers and also with text. And we got something on the screen. Not too bad to get started with. Now let me have a closer look at our text here, at our string, which we're combining from a couple of substrings. Now for one, I mentioned that you can use single or double quotes, and the decision is really up to you. You can go for either of the 2 solutions. I will use single quotes throughout the course, but that's just my personal preference, not something you have to use. However, you should be consistent and stick to your choice thereafter. What you can't do is mix your characters. So you can't open a string with a double quote and try to close it with a single quote. This will not work. You always have to close a string with the character, so with double quote or single quote, with which you opened it. So this string here, for example, is opened with a double quote, and then I have no other double quote, therefore this string never gets closed. That actually, therefore, is invalid JavaScript code, and hence my IDE already complains here that this is an unterminated string literal, so that this string has no end. And if we would try to run this code and reload our page, indeed, if you look into the developer tools again, you'll get an error. Now, the interesting thing actually is if I do close it with a double quote, now everything in between will be treated as one text. So when you open something with single or double quotes, everything in between the opening and closing single or double quotes will be one piece of text, which makes sense if you think about it. How would JavaScript know whether you want to create a new string there? There also is nothing like a string inside of a string. Instead, if we now reload the page, we got rid of our error, but now our whole we want to create a string code is actually treated as one piece of text and therefore output as such here. So you always have to close your string with what you opened it, and everything in between will be treated as text. Now you can take advantage of this if you, for example, want to print this single quote character. Because right now, if I use just single quotes and no double quotes, and the same would be true if you were just using double quotes and no single quotes, if I reload, we get the output we saw before. But what if I actually did want to output a single quote character here? Well, then you could try to add a single quote inside of a single quote, but this won't work. Instead, what now happens is that JavaScript creates a string here and creates a string here, and in between it has this bracket, which actually leads to some invalid JavaScript code overall here, because we're not using any operators that would try to concatenate that. And even if we would, a single opening bracket like this is not valid JavaScript code. So if you want to output the single quote character, you can actually take advantage of the double quotes and, for example, wrap your code, your string that contains the single quote which you want to output, between double quotes. Because now we use double quotes to create the string, everything in between is treated as text, and therefore if we save that and we reload, now we see the single quotes here as well. So that's one way of outputting single quotes if you wanted to. You could deviate from the rule of sticking to either single or double quotes and make an exception if you really want to output the single or double quotes you otherwise use as your string delimiters. Here, of course, I don't really want to print my single quotes, so I don't need to do that. Now we'll dive into strings again and again throughout the course because there are more things you can do with them. One thing I want to do right away is restructure this string. We're building our string here with 3 pieces of text, you could say, with the opening parentheses, with this code thereafter, or with this text thereafter, and with the value that's stored in default result. Now, in such cases, you can actually also use backticks instead of single quotes. So this is now not a single quote, this is the backtick character which you find on your keyboard. Get rid of all other single quotes you actually have, and get rid of these pluses you used to combine your strings, only keep the plus which you want to output on the page, and replace the closing single quote also with a closing backtick or with a backtick. So now I got 2 backticks which surround my text. And therefore now if I save this, unsurprisingly here I say default result instead of the value which is actually stored in that default result constant. But now backticks give you access to a special syntax. You can now use a $sign in here and then an opening and closing curly brace. And now you can put your variable or any expression which yields some result which can be output as text. So you could also have a calculation like 1 + 1 in here. So you can put that between your opening and closing curly braces now. And what this does is it tells JavaScript to output the value that's in this constant, in this case, in this place of your text. So it will not output the $sign or the curly brace. Instead, it will output the value of the expression, as it's called. So in this case, of the constant you have between the opening and closing curly brace. So if you now save that file and you reload, you see 0 here, which indeed is the value we have in default result. This only works with backticks. If you use single or double quotes, this $sign curly brace thing would be treated as regular text and therefore output as such, as you can see. So this is a really nice feature using these backticks with this $sign curly brace thing. If you have some text in which you want to embed or inject some dynamic value, so the result of some calculation or the value that's stored in a variable or of a constant, then this is simply shorter. It saves you the manual string concatenation, which we previously had to do, where we combined multiple strings with the plus operator. This is simply a bit shorter, and therefore how you typically would build a string that includes dynamic values. This overall construct here is called a template literal. So if you ever Google for JavaScript template literal, you'll find, well, exactly this piece of syntax. Now there's actually more to it, and we'll dive deeper into it throughout this course, but this is the most basic and I would say most important form of using it, because that's the form where you will work with it most often to have some text into which you inject or embed some dynamic value. Now, some additional information about strings and template literals as we have it here. One convenient thing about template literals is that you can easily write multi-line strings there. Now, with multi-line strings, I mean strings which really do have a line break in them. So let's say here, in front of the asterisk character, I add a couple of line breaks, and hence this string looks like that. Might look a bit strange at first, but this is valid JavaScript syntax. We open a string here, we close it here, and since it is a template literal with backticks, this is allowed. For a normal string with single or double quotes, this would not be allowed, but I will come back to that. Now, if you save that and you reload this in the browser, you'll not see a difference, though if you have the developer tools opened, which you can always open with View, Developer, Developer Tools, and you then click on this select icon there, and you select this part of your web page, you will see that indeed the white space is considered here. It's just the browser and the default behavior of the browser and the h2 element that basically strips this redundant white space. But it's output there, and depending on where you output this, in which element and how that element is styled, you might also get that white space or the extra line break here in your web page. So the fact that we don't see the line break here in the middle is really just due to how this is styled and rendered. If you go down here to the element style of the h2 element, which is selected, and you add white space pre, for example, then you will see the white space here as well, because this is some CSS styling which does not omit the extra white space, but instead render it. Here, in this case, that means it renders this extra line break. So you can easily add line breaks here when using the template literal syntax. This can help you with readability, because you might be able to read long strings easier or better here in the IDE if you add line breaks, but you should always keep in mind that this is not just a visual thing for you in the IDE, but that the line breaks really are part of the string. The same is true if you indent this. For example, you could think that if you write it like this, it's a normal string, but it's more readable to you as a developer. Well, if you save that and you reload, our styling will be lost because we reloaded, but here on the right you can see this extra white space, it really is part of the string. And if we re-add this style here to our h2 element here in the developer tools by setting white space to pre, you see we really do have the line break and the extra white space in here. So be careful when you use that, and really only use the line break or extra white space feature here if you want to build a string that has the extra white space or that has the line break. Don't do it just for readability. Now, if I come back to normal strings, there, let's say we have an error message, which we don't need for this app, for this website here, but just to demonstrate how we work with normal, which means non-template literal strings. Then, of course, you use single or double quotes, and you might have a message like an error occurred, something like this. If you would want to split this across multiple lines, you have two options. You can close the string here by adding a single quote and then reopen a new one and combine them with a plus and then add a line break. This is valid JavaScript code. You can span expressions that use operators across multiple lines. That would be possible here for mathematical operations, just as it is possible for concatenating strings with the plus operator. And here you can also indent, and if you do this, and you would output this somewhere on the web page, this indeed would not include a line break and also not extra white space, because this is really just something we do for us here in the IDE to make this more readable. The string that's getting constructed only consists of these characters between the single quotes. So there's no line break in there, and there is also no extra white space. Now, if you would want to add a real line break here in a string enclosed by single or double quotes, that is possible with a special character or a special combination of characters. You add a backslash and then n. What this will do if it would be rendered to the screen is it will not output backslash n there, but instead it will treat this as a line break. To show this, let's temporarily output the error message here instead of the calculation description, just temporarily so that we can see that. Now with that, if we reload here, we see an error occurred, and if we go back and add our good old style here to the h2 element right in the developer tools down there by setting whitespace to pre, you see the line break here as well, and you can also see it here. There is a line break after error. So with this backslash n, you can add a line break in a string no matter if you use single or double quotes. You could also use this here in the template literal, by the way. It's also supported there, but there you don't need it because there you can just add a normal line break, and since you're in a template literal, that will add a line break to the string as well. So there, this is available. Here in a normal string with single or double quotes, you need that backslash n thing. And by the way, using a backslash in a string has a special meaning. It escapes the character that comes after the backslash, which means the character after the backslash is not treated as a normal character with its normal meaning, but instead combined with the backslash, it gets a special meaning. In this case here, we escape the n, and therefore we don't just output the n here, but instead backslash and n combined mean line break. You have more such combinations, and attached you find a list of available shortcuts or combinations here in your strings. One other important combination, for example, is backslash and then a single quote. This is helpful if you want to output a single quote in your string, especially if your string is enclosed by single quotes. Without the backslash, we would have a syntax error here, because what happens is we open a string with a single quote. Here we then close it, and then here in this case we have a redundant single quote that tries to open a new string, which then never gets closed. So we have to tell JavaScript that this single quote should not be used as it normally uses single quotes, i.e. to close that string, but instead that we want to output this single quote here as a normal character in our text. And adding a backslash in front of it escapes the meaning the single quote would otherwise have, and therefore allows us to do that. Of course, an alternative always is to use double quotes to surround the string instead of single quotes. And then you can use single quotes in the double quoted string without issues and without escaping it, because it then won't have that special meaning of finishing your string or of closing your string, because you can only close a string with the character with which you opened it. And since here we opened a string with a double quote character, we can only close it with such, and JavaScript won't interpret a single quote as a please close my string character. Still useful to know that you could escape it like this. By the way, if you want to output a backslash in a string, you need to escape this as well, because otherwise a single backslash always tells JavaScript that the character after the backslash should be considered or should be escaped. So if you want to output just a backslash, you put another backslash in front of it to tell JavaScript, hey, the character after this backslash has a special meaning, and double backslash then effectively tells JavaScript, I want to output a single backslash here as part of my string. So these are some of the useful things that you should know about strings. You will encounter them throughout this course and throughout your career as a developer. You don't need to learn all these things by heart. The attached list of escapable characters might be useful, though backslash n, backslash backslash, and backslash single quote are the most important ones, I would argue, the ones you typically use most often. And being aware of the template literal, that you can interpolate content here, and that you can easily add line breaks and white space in here, that's also something which is good to know, I guess. And with that, I reverted all of that. Again, I'm sending calculation description to output result, and I deleted the extra error message variable because we don't need it here to continue. I just wanted to dive into some of these string specialties and things you should know. Now that we learned some basic things about variables and operators and data types, it's time for you to apply that knowledge in this assignment here. Now, these are your tasks, and attached you find this starting project, which includes these tasks. So you can simply extract the attached file, you find assignment.js, index.html, and style.css in there, move those into some folder of your choice, double-click the index.html file, and you get this page. Now, what do I want you to do? The first task, which you should solve in this assignment.js file, which is empty initially, the first task is that you create two variables. One that holds a fictional user input, and there you don't reach out to a real user input on the page as we did in our project, but you just pre-enter a number there. You pre-populate that variable with a number. So a number of your choice, and it should really just be a number like 15 or anything like that. And then create one variable that holds no value initially. For example, name that variable result. So it's just an empty variable with no value. Now in the next step, make sure that the result variable is set to 18 plus the value you stored in your user input variable, so that you combine these two values, 18 and the user input value, and store the result of that calculation in the result variable. Now thereafter add 3 additional code lines where you change the result variable again in each code line by subtracting a value of your choice, by multiplying it with a value of your choice, and by dividing it by a value of your choice. Now, thus far, by the way, you don't really see the output of these calculations on the screen. Don't wonder about that. We'll do something about this in step number 5. But first of all, step number 4. Think about the value you stored in the user input variable you created. Now, we changed the result variable. Did this also change the value in the user input variable? What do you think? Now, last but not least, after you thought about this and have a response for that, make sure that you alert the result and user input values in 2 separate alert calls. So you simply use this alert thing here, which we also used briefly, to put result and user input between these parentheses here in the 2 alert calls you have. So alert result and alert user input. This will then open alerts on the screen once you reload it, and there it will show you the value stored in result and the value stored in user input. This will then also answer question number 4, whether user input changed, and it will show you whether your result calculation is correct, because you can of course manually see what you expect as a result and what you get there after your steps. Now this is the assignment. Now don't provide your code as a response. That's not the idea here. Solve this for your own instead and only share your thoughts, the challenges you faced, and how you overcame them as a result. But do compare your result to mine, both to my solution video, which is part of this assignment, and my solution code, which you also find there, to make sure you can rule out any errors. Good luck with it, and see you in the solution. So let's dive into the assignment.js file, which is already getting imported here, so nothing we need to do there. And let's dive right into task number 1, creating 2 variables, one for the user input and one for the result. Now I'll create a variable, user input, with the let keyword, and regarding the naming, I'm following this best practice convention of using camel case, where we start with a lowercase character, and then each word in the word is not separated with a white space or anything like that. This would actually be a syntax error, but simply starts with an uppercase character. So user input, and I can set this to an arbitrary value, and there I will set it to, let's say, 20. I'll add a semicolon. It's optional, but it's the style I like, and therefore I'll be consistent about this. And therefore now we have our first variable with the assignment operator here. I'm assigning a value of 20 to that variable. We now also need to add that other variable, the result variable, which initially doesn't have to have a value, and therefore we can finish the line like this. This is now an uninitialized variable. It's declared with the let keyword, but not initialized, and that's totally fine. That is something you can do. Now that's already task number 1 solved. Now for task number 2, I need to add 18 to my user input and store the result of that in the result variable. So here we can just write result and set this equal to assign a value to result, set this equal to 18, which is the dummy value I should use, plus the value stored in user input by referring to user input like this. Here we use the plus operator, we use our variable and the value in there, therefore we combine these two numbers, and the result of that, thanks to the equal operator, is stored in the result variable. Now that's task number 2. Task number 3 is that we basically repeat this, kind of, but now with subtracting, multiplying, and dividing with numbers of our choice. So I will add result and set this equal to, and now I want to use my current result and subtract the number of my choice, like 10. By the way, if you interpreted this in a different way and you thought that you should reuse the user input and subtract a value of your choice, that's of course also fine. Then you could have user input minus 10 here. But I will alter the result over all these lines. So I subtract 10, so I should have 28 after subtracting 10, because I got 20 plus 18 is 38, minus 10 is 28. I will then take my result and multiply it with 2, that should give me 56. And then last but not least, I'll divide it by, let's say, 4, which should give me a value of 14 in the end for my final result. Now the question is whether the user input variable also changed with all these changes. Now what do you think? It of course does not change. We store 20 in user input, and then we add user input and therefore the value stored in there to result, but this does not affect user input. This does not change user input in any way. And therefore user input is never changed in our code. Therefore, and that's a total optional bonus point, you could turn user input into a constant by using the const keyword instead of let, because we're never reassigning a value. We're never having an equal sign after user input again, which means we never try to assign a new value to user input. Therefore, it never changes. Therefore, it's constant. Therefore, we can write it like this. Again, this is totally optional. If you stick to let here, that's not totally awful or wrong. And I also didn't ask you for changing this to a const. But if you did that, you get a bonus point. Otherwise, it's no problem, but you can do that because it never changes. Now, last but not least, let's alert result in user input. So down there, let's alert result, and let's also alert user input here. And with that, if we now save this file, we go back here and we reload this page, we see an alert of 14, which indeed is the result of my calculation. I said earlier that 14 is the expected result there, so this makes sense. And if I click OK, I see the alert for the user input, and this, as I said, is still 20 because this does not change. So that is all as expected. So this was a basic assignment which hopefully helped you understand variables and how you work with operators a bit better. Of course, feel free to play around with that a bit more. For example, create more complex calculations there, add more variables, whatever you want. For now, let's continue though. So now we got some core basics out of the way. We're able to work with some basic JavaScript with variables, constants, operators, numbers, and strings, and we're outputting that here on the screen. But the calculator, of course, is not very responsive. All that's getting output here is kind of hard-coded into the script here. We're not using any user input. We're not really doing something when the user presses buttons here. And therefore, this is not really a dynamic script. Instead, it just runs from top to bottom when we load the page, and therefore it immediately runs when the page gets loaded, and it then, well, does all these steps and outputs the result here, which is nice, but again, which isn't really something interactive or dynamic. So it's time to change that. And for that, we need a brand new language feature, which I haven't talked about before, and that would be functions. I like to refer to functions as code on demand. Now, what do I mean with that? A function is a language construct which you don't just have in JavaScript, but also in other programming languages, which basically allows you to define some code, which you then execute at a later point of time. You define a code in JavaScript like this, you use that function keyword, then you use any name you want for that function, then your function can take something which is called parameters, so some input to the function if you will, and then you have the so-called function body between curly braces, which is the code you want to execute eventually. Now, as I said, this function can have these parameters, so name in this example would be a parameter, and it can also return something, which this example function here doesn't, but which we'll see in action in this module. Now, when you have a function defined, the interesting thing here is that the code in there doesn't run immediately when your script gets first executed. Instead, JavaScript just sees that function and kind of registers it, stores it in memory, you could say. You then execute the code in the function by calling that function. You call a function by using its name, and then you add parentheses, and if that function takes any parameters, any input, which this function does, and you can have more than one parameter separated by commas, by the way, but you'll also see that. So if a function takes parameters, you pass in a value for these parameters. Then this code gets executed with the data you entered as parameters, and you can call such a function as often as you want, wherever you want in your code, with different parameters if it takes parameters. So every function execution then runs independent from the other previous function executions you might have had in your code. And the great thing about functions is that this now gives you way more flexibility. Because thus far, with all the code we write here, we basically write code which always executes from top to bottom when the script is loaded, which is the case when the page is loaded, and therefore all this code runs immediately. Now with functions, we can define code that should run later, and we can then take such a function and actually attach it to the buttons here to make sure that only when a button is pressed, the function runs. And this then allows us to write code which doesn't run immediately, but which allows us to provide some interaction to our website, to only run some code when something happens, for example. And of course, you're not limited to only running functions when a button is pressed. You can run functions based on a broad variety of events or manually call them in your code whenever you need to do that. And actually here, we are calling a function. I haven't really had a closer look at this yet, but output result is a function I provide to you because it's defined here in the vendor.js file with the function keyword, then the name of the function, then in this case 2 parameters, and then some code which is executed when the function is called. In this case, this code here simply reaches out to our HTML page, you could say, to our web page, and changes some text there. It displays the result of the calculation and this calculation text. So these 2 pieces here, which are changed in our web page, that's done by this function effectively, because this function communicates with that part of the HTML page with the help of these constants, which in turn set up connections to these places in the HTML code, you could say. So this function is registered here, and we can call it from that file because we import this file after the other file, right? The order matters, of course. So we have access to that function, and I'm calling that function here, as I explained on the slide, by repeating its name, then adding parentheses, and between the parentheses, I pass in the values to the function, which this function can use. So here I pass in current result and calculation description, so I pass in the values that are stored in these variables, and therefore this function receives these values, and that's important, it receives the values, not the variable names or anything like that, it receives the values stored in the variables, and therefore in this function we can then use these values to, in this case, output it in our HTML page, but you could do whatever you want with these values. So let's write our own function then, so that we get a better feeling and understanding for how functions work and what we can do with them. So which function could we write? Well, let's say we want to make sure that at some point of time in this module we can click the plus button and add whatever we entered here to our current result, which initially is 0, and then if we type 5 here and click plus, we want to get 5. So the new result is then 5. If I thereafter type 10 and I click plus, we would get 15, right? So that would be an idea to get started with. And for that, we need a function, or we could add a function that does just that, that adds two numbers. So for that, we can define a function, and it's up to you where you do that. You can actually do it kind of at the start of your script, maybe below your variable definitions, or you can actually also do it at the end of your script, and JavaScript is smart enough to kind of read your entire file before it executes it, and it will therefore find any functions you use so that it then automatically pulls these functions to the top, so to say. So that if you define a function down there, but you then use it somewhere above its definition, you can still execute that code without an error. Something which, by the way, is not possible for variables and constants you define with let and const. But I'll come back to this in a second. For now, let's just add a function here, let's say, and let's name it add, and you can pick any name you want here. The idea for the name here just should be that it describes the action this function will perform. So if it's a function that adds two numbers, something like add or add numbers makes sense instead of give me two numbers, which describes what it wants to get as an input, but not what it does. You also don't want to have something like result as a name, because what does this function do? It doesn't tell us anything. It gives us some result, sure, but for which operation? So here add sounds like a fitting name. It makes it clear that this is a function which will do some addition. And then, as I said, a function can but doesn't have to take parameters. Now in JavaScript, and you'll see that throughout the course, of course, there are functions which work without any input. Let's say you have a function which kind of reads something from the HTML page. This probably doesn't take any input because inside of the function you have all the information you need to kind of reach out to the HTML page and get some data from there. On the other hand, a function which should add two numbers probably needs these two numbers which it should add. So we should provide two parameters here. And you can give these parameters any name you want. So I will go with num1 and num2, but you could go with a and b, or with number1 and number2, or whatever you want. These parameters which you define here are then available in the so-called function body, which is the last missing piece on this function. You add the function body by adding curly braces here, like this. And now important, after the function you don't have a semicolon. Now you could add one, but typically you don't do that. You add a semicolon after all these one-line expressions here, but after a statement, as this is called, which includes such curly braces like this one does here, you don't add a semicolon. You can just keep this in mind. Whenever you have some curly braces with some code, some executable code in between, you don't have a semicolon after the curly braces. Whenever you have these short expressions here, you have a semicolon at the end. So here we have a function, keyword, name, parameters, which are optional, and then the function body. And now in the function body, you can do all kinds of things. For example, we can define a constant in here as well, maybe name this result, and just add num1 and num2 here. Now num1 and num2 are like variables, though they're never defined with the let or const keyword, but they're automatically defined by JavaScript, but they're only available inside of this function body, not outside. So if I would try to do something with num1 here, after the function definition, this would not work, because num1 and num2 are variables only available inside of the function body. Now I use them here to add them together, because I expect this function to be called such that whatever I get here on num1 and num2 are numbers, and therefore adding them works. And I store the result in a new constant. Now the interesting thing here is that this constant is defined inside of the function, not at the top level of our script. And that's something you can do in JavaScript, and that is actually quite normal. You can have variables and constants here at the top level of your script. This is also called in the global scope, but you can also have them inside of your function. And it's actually important where you define that, and I'll come back to that. For now, I want to calculate a result, which I only use inside of the function, and therefore we can declare and define this variable, or this constant actually, inside of that function. Now, inside of that function body, you see that my IDE automatically indents the code, which means it's not totally on the left here, but there is some empty space. This is done for readability. Technically, this is not required. Your code would run even if this would all be written in one line. So if you would move that right next to the curly braces and have that all defined in one line. But having the function split out across multiple lines and having this indentation, this empty space, simply helps with reading or understanding your function. Now, regarding the amount of empty space you have to the left, you can find a lot of discussions about that on the internet. Now here, I indented by 4 blanks, so to say, so 4 white spaces. Now you'll find discussions on the internet whether you want to use 4 or 2, whether you want to use tabs or white space. I'm a fan of white space, and I'll typically use 2. Also later, when I auto-format my document, it's configured to use 2 white spaces here instead of 4 as I have it right now. You can go with whichever approach you want. You then should just stick to it and be consistent. And you can also configure your code styling, your code formatting plugin for the IDE you're using to format your code according to your preferences. Again, my tool will later change this to 2 blanks here instead of 4 as I have it right now. You can go for either of that. You just should write readable code in the end. So this will now hold the result of num1 and num2 added together. And now what can we do with the result? Well, we can, for example, output it with the alert function. This is a function built into JavaScript or built into the browser and provided to you in JavaScript executed in the browser. So we don't need to define this function on our own to call it. It's available. It's one of the built-in functions. And there are a couple of built-in functions in JavaScript. It depends on whether you're running JavaScript in the browser or outside of the browser. But here we're in the browser, and there we have something like the alert function, which is, well, built in, made available by the browser. So alert then allows us to output a message. We could say the result is, and then this is a string, of course, add result here. And of course, you could have also used the backticks notation with this $sign curly brace embedding here. Now, I do create a string here where I concatenate my result because alert actually wants a message as a parameter. And you can see this if you hover over alert in Visual Studio Code. You see this is a function, again, provided by JavaScript or by the browser. And this wants a message parameter. We can ignore the question mark for now. That simply means that providing this message is optional, so you could throw an alert without a message, which is kind of pointless though. And message here is a parameter which actually, well, should be a string because you want to output some text typically. So now I'm outputting this text here, this alert. Now if I save this and we reload, nothing happens. We see no alert. And the reason for that is that we're not calling this function yet. As I mentioned, you need to call a function in order for it to be executed. Now, how do you call a function? Well, you can just use the function name. So in this case, add. And if you picked a different name, you have to pick a different name here. And then add parentheses like this. So a bit like you defined it here, but without the function keyword and without the body. Because this defines what's inside of the function, how it works. This now calls the function. And here I add a semicolon again, because here I don't have the curly braces, I don't define the function here, I just execute this as a so-called expression. So I just have this line of code which is executed. This line of code is also executed, but it's executed such that this code is registered and stored by JavaScript. So it kind of is made aware of this function. This line then executes and calls that function. It runs that function. Now this function, to work correctly, needs 2 parameters, also called arguments. It needs a num1 and a num2. And now here, of course, you don't provide num1 or num2, so you don't repeat these names. These are just internal names for these automatically created variables you can use inside of the function. Instead, here you now provide the concrete values that the function should use for running. So something like 1 and 2 if you want to add 1 and 2 together. So now num1 would be set to 1 and num2 would be set to 2. for this function execution. And as I said, you can now run a function multiple times by executing it again, with 5 and 5, for example. Now we would execute the function 2 times, one with a value of 1 for num1 and a value of 2 for num2. And then the second time we run it, we pass in a value of 5 for num1 and a value of 5 for num2. And now if we save that and we reload this file, you see, since this script runs right away, we get the alert with the result is 3, because here I'm, well, calling this function with 1 and 2. And if I click OK, I right away get another alert, because we're running this function twice, and script execution is kind of blocked by the alert, which is why the second alert waits until we dismiss the first alert. And in that second alert, I see the result is 10, because I called this function with 5 and 5. And if I dismiss, well, then we see that page being rendered. So this is how we define a function and how we call it in JavaScript. Now I will emphasize again that a function can have as many parameters as it needs if it needs to have some. You can have 1 parameter, 2 as we have it here, 3, 5, 4, as many as you want. And a function can also do one other thing, which we're not doing here. It can return something. This function here executes the code which is in there, and in this case this then throws this alert or shows this alert box by calling the built-in alert function. Now that's something you can do in other scenarios, which we'll also cover later in the course. Of course, you might want to send a HTTP request to a server and store some data there, for example. But sometimes you also have functions which you just use to outsource some code. Maybe code which you need to run multiple times, and therefore normally you would have to copy and paste it around, which never is a great idea as a programmer. You want to be lazy, you don't want to repeat yourself, you want to write code once and then rather execute it multiple times by referring to the function it's coded in. And therefore you could have a function which is simply there to outsource some functionality. In this case, a function that adds 2 pieces of information together, which adds 2 numbers together. So in that case, you might not want to alert or do something inside of the function. You maybe just want to return the result. And that's something you can do with the return keyword, which is built into JavaScript. So now we saw a couple of keywords: const, let, function, and now also return. And return does what the name implies. This function now returns the value that's stored in a result as a result of this function call. This means that when we now execute add like this, nothing will happen if I reload the page. You see, nothing happens. We don't see anything, because now the function itself doesn't do anything that has a visual impact. Instead, it returns a value. So that means that add now gives us a value, just like the plus operator or the multiplication operator gave us a value. If we add 2 numbers together, this gives us a value, and we store that value in a constant. So now calling our function gives us a value, and that means we can store this in a variable, for example. So here we could say, I want to have my addition result, and you can pick any name you want, stored in this constant. And I'm using a constant here, just as I do it here in my function, because I never assign a new value to the addition result or here to the internal result. I never assign a new value with the equal sign again. And if you never assign a new value, then this effectively is a constant, and then you should mark it as such to make it clear that this will never change. Makes it easier to understand your code for other developers. So now the result of this function call is stored in addition result. And this means that we can now use it anywhere in the code. For example, we could now use addition result to set our current result equal to it, like this. Of course, this is now kind of redundant. We store the result of this function call in a new constant just to take the constant or the value stored in a constant and then set it equal to current result, to our variable. Of course, we can kind of shorten this and just set current result equal to the result of our function call and get rid of that other line. And now current result is the result of this calculation. So that means, of course, that if I now reload this, we see 3 down there for the result. because I have add with 1 and 2, the result of this is 3. The result gets stored here, and then we use current result to pass it to this output result function, which is provided in the vendor.js file, which will in the end output the calculation result in this place of our HTML document. Of course, this is now incorrect. This is now not the correct description of what we did. So this is how we can define our own functions with or without parameters, with or without the return statement, and how we can call them. Now, of course, we're still calling this immediately when this code runs. So ultimately, the goal will be to connect this to the button, which I'll do in a second, but not before diving into the order in which you can define things here, and also the implication it has when you define a variable or a constant inside of a function versus outside of a function. Let's have a look at the order. Here, I'm defining my constant and my variable before I use it, right? I define current result right at the top of the script file, and then here's the first time where I try to use it because I try to assign a new value to it. And then I also use it down there when I forward it or when I pass the value that's stored inside of it to output result. Now our code would break if I would move that all the way to the bottom of the script. So if I declare my variable here. Now if we reload this page, you see 0 everywhere. And if you open the developer tools again, in the console, you'll see an error, cannot access current result before initialization. Now this error message, which the browser throws at us, is pretty clear. We're trying to use it here, and actually the error message even gives us the line number of where this error occurred. It's this number you see here, 8. So as you see in line number 8, and indeed that's the problematic number here, we're getting an error because we're trying to assign something to the current result variable without defining it first. So in JavaScript, when using the let or the const keyword, which you should use, you need to declare your variables and constants before you use them. And declare is the part where you, well, create the variable with let or const. Then, as mentioned, for the same name, you must only declare it once. You can always reassign a value, but with let and const, you only declare it once, and you need to do that declaration before you first try to read from it or assign a value to it. You don't need to define it, so you don't need to initialize it with a value. If I just set up current result like this, this would actually be valid. If I now try to execute it, you see this runs because I declared a variable before I then use it. And since I use it by initializing it with a value here anyways, or by assigning a value here anyways, I don't need to initialize and define it up there. So doing this up here is totally optional. We don't really need to do that because I'm assigning a value down there anyways, but you need to declare it with the let keyword. Now for functions, that's actually a bit different. I could grab this function and move it to the bottom of this file. And if I do this, please keep in mind that I do call it up here. So technically before I define it. Still, if I now reload this page, we get the same result as before. And if we have a look into the developer tools, you see no new error here. The reason for that is that for functions, we have a special behavior in JavaScript. What JavaScript actually does, or what the browser actually does, is that when it loads your script, it runs through it from top to bottom, it parses the entire script, and actually it doesn't execute it right away. Instead, it just reads it from top to bottom, and will take any functions it finds in there and automatically pull them to the top and be aware of them, so to say. So it automatically registers all functions before it then really executes your script. And that's just a special behavior JavaScript has there. Therefore, it's up to you whether you prefer to have your functions at the bottom of your script or towards the beginning, or somewhere in between. You just should try to find some consistent code style. Now, I personally like to have my functions towards the beginning of the file in most cases, because I think if you then read the file as a developer, you kind of see what's in there, and if you then later see that I call add, you recall that you did see that function definition above, and you don't need to scroll to the bottom of the file to find it. But there also are developers who prefer to have their function definitions at the bottom of the file. And ultimately, there is no wrong or right, it's up to you, but you should find one approach and then kind of stick to it for this program you're writing. Of course, you can switch anytime in new applications you're creating, or refactor your existing code and move your functions to the bottom or to the top if you kind of decide to go the opposite direction whilst in the project. Here again, I'll have it towards the beginning, but this is up to you. Let me also reformat that, which I did with the auto formatting functionality I showed you in the first course module. So the order matters for variables and constants. It does not for functions. There's one more interesting thing in our code here, and that's that we have a constant here in the function, and we have a variable and a constant outside of the function. Now, when should you use what, and what's the difference? Is there a difference? Well, there is a difference, and generally, if you use some data only in the function, like this result, which I use in the function, I return it here, then you want to define it in the function. I could have said, let result here, and then just assign a new value here, and then we could even do something strange. We could say, add like this, and set current result equal to result. This code would technically work because what I'm doing here is I'm defining this result variable globally, so in my script. Then I assign a new value to it in a function, because in your functions, and that's one important thing to keep in mind, you can access any variable or constant defined outside of the function. So you can read variables or constants defined globally. So we can interact with this result variable, and I'm assigning a new value to it. And therefore, when I thereafter call the function, I actually don't care about the return value. I let that go into the void. But since inside of the function, I assigned a new value to result, I can use that global variable and store it in another global variable or use it anywhere else, whatever you want to do. This, however, would not be very good code because we have a function that manipulates a global variable. That's sometimes something you want to do, but often that makes your functions harder to understand and harder to predict what they're going to do. And in addition, that we return this value here is totally redundant, so not the best code we could write. Instead, it's way better if we go with the setup we had before, where we have our contained constant here, we return this, and the function therefore works standalone. It doesn't magically change our global variables. Instead, we know when we call the function, this function will not alter anything, not anything global. Instead, it will only work with its internal data and then return us. This is called a pure function. It gets some input, returns output. For the same input, it always returns the same output, and it doesn't manipulate anything global. But it is worth noting that functions can access global variables. They can also access other functions you might have defined. So you can call a function from inside a function. And that is built into JavaScript, and it's a good thing, which we'll also use from time to time. Now, the other way around won't work though. If you define a constant or a variable inside of a function, then this has a so-called local or block scope, which means it's available inside of this block. The block is surrounded or marked by these curly braces, and we can use it anywhere in this block, but we can't use it outside of there. So if I try to throw an alert where I want to output the value that's stored in result here after defining the function, you'll see that if I reload this, nothing happens. You see, we seem to have an error, and indeed, if I open my console in the developer tools again, I get a reference error that result is not defined. Because I'm trying to use a variable here in line 9, so in this line here, which wasn't defined. Because, as I just explained, you can use global variables and constants and functions inside of functions, but you can't use local variables or constants or functions, so variables or constants or functions defined inside of functions. and yes, you can define functions inside of functions, something I'll dive in later. You can't use those from outside of the function. So using result outside of the function won't work because this is a constant defined inside of the function. And it won't work no matter if we use it here or here after we called the function. Because you could think, well, we only called the function here, so thereafter result has to be defined and now it should be available. Well, actually, as it turns out, if you now reload, you still get the same error here. Now in line 11 instead of line 9 because I moved that code, but still result is not available outside of the function. And that's one important thing you need to understand with JavaScript. Functions have full access to their surrounding context, so to all the variables and so on that are defined above them or outside of them. But what you define inside of a function is only available in there. The only way of kind of getting it out is by returning it. Now, at this point, you might also wonder, what if a variable is defined globally and then we try to create it locally in a function as well? So we have it declared with let or const globally, and then we want to do the same with let or const in the function. So not overwrite the existing one, but create a new one. Is that possible? And the answer would be yes. This is a process called shadowing. And in the lecture after this one, I'll dive a bit deeper into this. So the return statement is useful for getting data out of the function. There are a couple of important things to know about the return statement. For one, any code that you have thereafter, like this alert, won't execute. You see my IDE even kind of grays it out a bit. And indeed, if I reload the screen, you see everything works, but I never see that alert. In the developer tools, you'll also not see an error though, because the app didn't crash. We don't have an error. The return statement just ends the function execution, which means code thereafter isn't executed. You, by the way, also can return nothing. You might wonder why you might want to do that. For this function, it makes absolutely no sense, but you will later encounter scenarios where a function does something. Let's say it does some calculation and then sends that with a HTTP request to some server to store it there. And then you want to quit function execution, maybe conditionally with something we'll dive into later with the if statement, which allows us to check for some condition, and then exit the function if that condition is true and only continue if it is not true. So in such cases, you could return from a function and you would return nothing just to cancel function execution. Here, again, that doesn't make any sense because the function would be over after this line anyways, but it's important to understand that return finishes the function execution in case you had more code after this, which, as mentioned, only makes sense if you have some kind of conditional logic in your code. Right now we don't have that, so it makes no sense. You also must only have one return statement here. Or actually, well, you could have a second one, but because the function execution stops after the first one it finds, having a second one makes no sense. So it's not a technical error to have more than one, but you can't return more than one thing here. If you need to return more than one piece of data, actually, we'll find a solution for that later. For now, we'll just use it like this, but we'll dive into other data constructs which allow us to return or contain more than one piece of data later in this module. So there was a lot of talking about functions and variables and constants, but these are some core things you gotta understand with JavaScript regarding how code executes and how code is related. Now, our goal was to make sure that when we click the plus button, we actually take whatever the user entered here, and we then use that in this addition and generate a new result, which we then output. Now, for that, we need to add an event listener to this button. And now that's something we haven't learned at all. We don't really know how to interact with the HTML page because that's a bit more complex, and I'll have a whole module where we dive into all the depths of this. For now, we can take something from the vendor.js file. We can take this add button, which at the end is a reference, a pointer at this plus button we have here. So in app.js, we can use that replace this code here with add button, and then add a dot here, which is strange. We have never seen that before here. Let's ignore it for now. And then type add event listener, written like this. This is actually a function built into the browser, you could say, which is tied to this button, which is why we have this dot in between. And we'll dive a bit deeper into what this dot means in just a while. So for now, let's just write this. And now this is a function that takes two parameters or two arguments. And the first parameter is actually a string, which identifies the event to which we want to listen. Now, there are a bunch of available events, and I'll walk you through them and where to find them all in the dedicated module. For now, we can add click here. Now, as a string between single or double quotes or backticks, though backticks don't make a lot of sense here because we don't need to embed anything dynamic here. So that's the first parameter. The second parameter, and that's now the strange thing, actually should be a function. It's not that strange if you think about it though. Since functions are code on demand, you want to make sure that you tell the browser, that you tell JavaScript which function should be executed if this button is clicked. So how do we now point at a function here? Well, you could do something like add here, right? You could execute your add function here. Now, this would actually be wrong. And this is one of the trickier things to understand in JavaScript or in programming in general. It's not exclusive to JavaScript. We want to tell the browser what to execute when a click occurs. Now, if we execute add like this, no matter if we add arguments or not, which we of course should theoretically though, what happens is that this code gets parsed by the browser when it encounters our script, and in the end, after registering all functions and so on, it will go ahead. It will add this event listener, but then this here tells the browser, call this function, because we have parentheses with arguments here. We want to tell the browser, however, or we want to tell the JavaScript engine, don't execute this function right away. Instead, keep in mind that this function should be executed when this button is clicked. The solution, therefore, is to not pass the function here with parentheses, but just the function name. By doing that, you're telling the JavaScript engine, when this button is clicked, have a look at the function with this name and execute it for me. So before we manually called the function in our code, because we the developers, so to say, were the one executing the function. Now we want to make sure that the browser can execute the function when the click occurs. And we don't know when that will be the case. So we want to give JavaScript the name of the function which it should call for us. We want to allow the browser to call that function for us. Here's a real-life analogy. You live in some house, some flat, and you have an address where you get your mail and so on. Now, of course, you can go down to your doorbell and ring it yourself. You can do that because you know where you live and what your doorbell is, which button you need to press. But you want to make sure that the mail service, the people delivering your mail and your packages, that they know where to ring. So you give them your address. You give them your address by providing it to Amazon or wherever you order your stuff. So now you basically tell them your address, and in this case, the name of the function is the address, so to say, where they need to ring. So that when they are there with your package, with which you ordered, they can ring that bell. And that's the same we're doing here. We're giving the browser the address, the name of the function, which it should call for us when the button is clicked. So now this add function will be executed for us by the browser whenever the user clicks this add button. The thing now just is, what about these arguments which we want to get there? We don't know what to add here. Well, in the end, what should be added here is the current result and then whatever the user entered. So we need two additional pieces of information. We need to find out what the user entered, and we need to get our current result. For that, we can restructure the function a bit, and instead of getting arguments here, we can take advantage of something which I mentioned earlier. A function can read from the globally available variables. So we know the current result, of course, so we can use that here in a read-only way, so we're reading from it. We could, of course, also reassign a value to it, but here I'm just reading from it. And now I want to get the value the user entered here. Now, for that, the vendor.js file again got us covered. This user input constant, which is added globally here, that in the end points at this input field here. So we can use user input here, but now that's just a pointer at the input field. Again, without diving into too many details here, you can add dot value here, and that will actually give you the value of what the user entered. And now we get these two pieces of information from our globally available variables and constants. We then derive that result, we return that result, and of course that's another problem. We return the result, but we don't really care about the return value here. We're telling the browser when the button is clicked, click the add function. The browser, however, doesn't care about our result here. It just knows on a click, I execute this function. I don't care whether you return something, and if you do, what that would be. So we can actually change that to on that function and just make sure that we immediately change the current result. And earlier I mentioned that it's not the best idea for a function to kind of change something from outside. Well, if it's a function like this, which is very clear about that, which doesn't kind of mix some internal constant and some external global values, but which clearly only works with global values, which we just use as an event listener, that's kind of fine. And this might sound totally arbitrary right now. You'll get a feeling for this throughout the course, promised. This is something which gets clearer the more you work with JavaScript. You in the end just want to write clear functions which might work with global constants and variables, but which then shouldn't mix it too much with internally managed data and then some returned value, even though they're also manipulating some global value. As a general rule of thumb, you can have a function that manipulates some global variable, but then this function maybe also shouldn't return something. Because if a function returns something, it kind of signals, hey, I do something and I give you the result of that. I don't do anything else than that. If that function then starts changing something else too, that's the confusing part. If you have a function without a return statement, as we have it here, this function doesn't give us the illusion that it would return its result. It probably instead starts editing the global variables right away, which it does. And then this is clear to us as a developer if we read that code as well. So this now again makes sense. Well, now there was a lot of talking, but we now should have a setup where we actually are able to change the current result when that button is pressed. So if we now saved it and we reload here and I enter a 5 and I click plus, nothing changes. Now why is that? Well, we're almost there, but keep in mind that we're calling output result here at the end of our script. Now, as I mentioned before, the script runs from top to bottom, right? So that, of course, means that after that, it's done and it doesn't run again. The only thing that runs again is this function whenever we press that button, because we, when the script executed, told the browser to be aware of that click listener. And it then registers the click listener, and it will, even after the script completed, then always execute this function, because it stored that in memory and all the surrounding data it needs, whenever the button is clicked. Output result, however, is not executed when the button is clicked, but when the script first executes. So what we do here is we try to write to our page, but we don't do that whenever the button is clicked, and therefore when our current result changes, but only when the script initially runs. So the solution is to grab that piece of code and also add it into the add function, so that now here we output our result. And now we can also soon start adding a calculation description again. For now, I'll just replace it with the empty string. But the more important thing is that now it uses this current result here, and it now outputs that into our web page whenever the add function runs. So if we now save this, and I reload, and I enter 5, and then I press plus, you see result 0, 5? Let's add a 10 here this gets stranger and stranger. This is clearly not a valid calculator. So the good thing is, we're seeing the output here. So generally, our setup with the function and so on seems to work, but we're clearly not doing some mathematically correct calculations here. So what's the problem? It's again time to practice the things you learned in another assignment, this time about functions. Now again, attached you find a zip file with 3 files in there. That would be the index.html file, the almost empty assignment.js file, and the style CSS file. The index.html file already imports everything you need. And with that, let's have a look at the tasks you should solve. The first task is that you create 2 new functions. One that takes no parameters and simply shows an alert with some text of your choice, something like hello there, whatever you like. And one, so the other function, that receives a name as a parameter and then uses alert to output the name. So a function where you can pass in a name like Max and then you see hi Max when you call that function. Though at this point of time, just create the functions, don't call them yet. In task number 2, you should then call the functions, however. Now, task number 3 alters this a little bit. There, you should add an event listener to the task3 element, which already exists in the assignment.js file. So to this, with the add event listener function you also saw in this course thus far. And there, attach the first function, so the function without parameters, as an event handler, and make sure that you thereafter click this task here. This is clickable thereafter. And, well, you should then see the alert which the first function shows, instead of manually executing the function which you did before. The other function which you manually executed in step number 2 should still execute manually. So directly from within your code, I mean. Now in task number 4, you should add a brand new function which takes 3 parameters, 3 strings. You can give the parameters any names you want, which returns 1 combined string. And I fixed the typo here. So which returns 1 combined string out of the 3 strings it gets as a parameter. So in the function, you basically concatenate these 3 strings with one of the string combination techniques you learned about, and you then return that string. Now, to see the result of that, in step number 5, you should call that function directly from inside your code and use the result in an alert call of that built-in alert function to output what that function returned directly on the screen in such an alert box. This is the assignment. Just as before, the code is not what you should share. Instead, just share the challenges you faced and how you overcame them, and instead take my solution video and solution code to compare your solution to it. With that, have fun with the assignment. So let's solve it together. Here's my solution. Let's of course start with step number 1, where we create 2 new functions, one that takes no parameters and just shows an alert, and one that does take a name parameter and shows an alert that outputs that name. So here I'll create a new function, first the one without parameters, where I just say greet, and you can choose any name you want, of course, for this function. So I'm assigning a name to the function, then an empty parameter list, which we still need even if it's empty, but well, it's empty. And then the curly braces that surround the function body. And in there, I just want to have my alert with the semicolon thereafter. I omit the semicolon here. You could add it, but it's typically not something you do. And here I'll say, hi there. So just a random message. Now that's function number 1. Function number 2 should take a parameter, and therefore I'll name this greet user. Again, the function name is totally up to you. And in there I get my parameter, which again, you can name however you want. You can take name as a name or a username or whatever you want. This will essentially be a variable defined in that function thereafter. So I'll go with username. And therefore we can now use this variable inside of the function. And here I can say, hi username. Like this, for example, by concatenating the username string, which I expect with this hi string and a white space to have some space between the words I'm outputting. Now that's task number 1. Task number 2 is to call these functions. Well, for that, in our code, we can just write greet, the function name, and then a pair of parentheses to execute the function. And the same, of course, for greet user, but there between the parentheses, we have to provide a value which will then be used inside of the function in this username variable. So here I could say Max, which is my name. Of course, you can pass in any name you want. It should be a string though, because, well, really only makes sense with a string, right? What would you do with a number? You would greet a number, would be kind of strange. So let's do that. Let's save this and then reload this page. And you should see hi there. And if you dismiss this, you see hi Max in my case. So that's working. Let's move on to step number 3. There, we now should trigger the first function, not directly from inside our code, but instead by attaching it to the task-free element here. So in my code, I'll remove this here, and instead add task-free element dot add event listener. Task-free element, of course, is this constant up there, which basically establishes a connection to this element here. And the event listener I want to add is a click event listener. So that's the first argument or first parameter we provide to this built-in function. And the second argument, the second parameter value separated with a comma, is then the function that should be executed. And here that should be greet. Now important, as you learned, without parentheses, because I don't want to execute it right away when JavaScript parses this line of code, or when it first reaches this line of code. Instead, I want JavaScript to register that it should eventually call greet when this click occurs. That's the idea here. So now if we save that and reload the page again, we get this alert. If I close this and I now click on task number 3, we see that hi there alert. So that is working. Task number 4 is to add a brand new function with 3 parameters, 3 strings, which then are combined to one string, which then is returned. So I'll add a new function. I'll add it here. You could also add it further below if you wanted to. And there we'll get 3 values, and you can give these parameters any name you want. A function name would also be nice though. I'll name it combine. And for my parameters, I'll use str1, str2, and str3, which is very creative, of course, for string 1, string 2, string 3. Again, the names of the parameters, just like the function name, is totally up to you. And then here I want to return the combined strings. So I'll create a new constant, combined text here, where I basically concatenate the 3 strings. And the easiest way of doing that is this here, by just using the plus operator that works with strings and concatenates them. And then we can return combined text. Of course, we could also immediately return this if we wanted to. I just used the extra constant to make it a bit more readable. So that's one way of combining this. Now, if you want to add some white space in between, you would have to change it to this, where you add that extra white space string. Or you use the more convenient variant of creating that string, where you use backticks to use that interpolation syntax, where you can use $sign curly braces to output string 1, then some regular text, in this case the white space, and then string 2, regular text, and then string 3. So that's also an alternative. With that, I return that text. Now all we need to do in task number 5 is that we call that function. We then also store the result somewhere and output that with the alert function call. So maybe down there we can have our combined string, which we get by calling combine, and then here we need to combine text. So hi there, and maybe an exclamation mark. So this is now the text I'm building. And then we can alert the combined string here. Side note, you could also directly call combine with your values here in that place. So you can always replace a variable you use somewhere with the value that's stored in that variable. I just find it more readable if we have that clean approach of storing it in a constant and then using the constant here. So now with that, if we save that and I reload here, I first get the hi max alert. Then, however, I get my combined text, which is hi there exclamation mark. So this also works. And that's task number 5 solved. This is the entire assignment solved, and this hopefully again gave you some extra practice with functions, how to write them, how to use them, how to work with parameters, how to return values, and what the idea behind functions really is. The problem is the type of the value we're using here. Current result in the end is a number, right? We start with 0 here. Now what we add to current result here, however, and that's something you just gotta know, which is why I tell you, is a string. Because I'm getting this from this user input, and even though I entered a number here, and even though this user input actually even is of type number here in the HTML code, whatever you get from a user, from an HTML input in your JavaScript code will always be a string. Just something you can memorize. An input element, if you read its value, will give you a string. That's how JavaScript in the browser works. It doesn't try to be smart and check whether that should be a number or not. It doesn't make any assumptions. It just gives you a string, text. And therefore, what happens here is that we have a number and we have some text. And now JavaScript is it has a problem because we're trying to combine a string and a number. And how would it do that? Well, we saw how it does that earlier when we built this calculation description. There, we also combined text with a number because the default result we used there was just a number. And JavaScript concatenated that to one long string. And it's the same here. It got a number and a string. Instead of converting both to a number and doing a calculation, it does the safer thing because it doesn't know whether what you entered here as a string could be treated as a number or not. And it therefore simply converts it to a string and concatenates it to a string. And that's what we see here. We started with an initial value of 0. It concatenated 5. Then we had 0, 5. It added 10. So this is now that one long string which we got. And again, it does so because it doesn't know whether what you entered here can be used as a number or whether it just is some character which it can't use as a number. Therefore, the default is that it builds a string here. Now, of course, we want to build a number here, however. And we know that whatever the user enters here should be a number so that it can be used in mathematical equations. Now, how can we convert this value to a number then to tell JavaScript that we have a number and it should therefore do a mathematical calculation instead of string concatenation? To convert this to a number, you have a function built into the browser or built into JavaScript, a bit like the alert function we used earlier, which is called parse int. You also have parse float. The difference is that parse int will try to parse some text, so a string, as a number without decimal places. And parse float will do the same with decimal places. So with parse float, if you entered 10 here, this will be parsed as 10.0. With parse int, if you entered 10.1 here, which actually this input doesn't allow, but if you would do that, it would give you 10. So parse int and parse float are functions built into JavaScript that will, in the end, take a string as an input, take a string as a parameter you pass in, and will then convert this text into a number. Now, of course, that can fail. If you had some text here, like hi, which again, I can't enter here because this is configured to take a number, but if you would have hi here, parseInt would actually, of course, not be able to convert this to a number. Instead, it would convert it to a special value, which I'll show you later. For now, we know we get valid numbers and therefore we'll be able to parse it. I also only work with non-decimal numbers here, so only with integers as it's called, so numbers without decimal places, and therefore parseInt will work. So now if I save this, we're doing a calculation here with a number and the number, and hence if we reload and I enter 10 here and I then click plus, we see 10 here. And this is now not 0, 10, so not some concatenated string. Instead, if I enter a 5 and I click plus again, I see 15. So this is now a real number. Now, instead of parseInt, you can also use a plus here, by the way, even without parentheses. So we have a plus here, that's the operator. Another plus in front of the string will then also convert this string to a number. So that's the shorter form of doing that conversion. And it's up to you whether you prefer the plus or parseInt. ParseInt and parseFloat is of course more explicit about what it's doing. The plus here is easy to overlook. And if you know I want to have a non-decimal number, or I absolutely need a decimal place, well then parseInt gives you that extra control. The plus will just give you the best fitting number. So if it's a number without decimal places, it will keep that. If it's a number with decimal places, it will keep that as well. So parseInt and parsefloat also allows you to be more specific about which kind of number you want. Now, if you ever would want to convert a number to a string, you could do this as well by adding dot to string. That's another built-in function tied to the number here, which converts this number to a string. This, however, is definitely used in less cases, I'd say, because more often you need to convert a string value to a number to use it in a calculation than the opposite way around, because as you saw earlier, the default of JavaScript was to concatenate two strings. So we had that default behavior of treating this here, or using this number here, in a string anyways. So with that out of the way, we're doing that conversion correctly, and the add function is working therefore. Now we can still improve this function a little bit, or improve this overall code, and also of course improve the output we're outputting here. So let's work on the output here of our log of the calculation we did, so to say. Here I in the end want to output the last calculation we did. And for that I want to output a string here, and I'll create it with backticks so that I can inject values dynamically with this $ curly brace syntax. Because what I want to output is current result plus, and then the new result. Now, the problem we have with that, of course, is that after this line, our current result already changed. So I rather create this description here, maybe just name it description or calc description or whatever you like, and grab the template literal as it's called and move it up here. And then here I refer to current result before we change it, because I run this line before this line. And I want to add my number here. So I can copy this code and add this here as well. And actually, we of course don't need to parse this as an integer, because I will need it as a text anyways. We're building a text here after all. So I can also just use it like this. Side note, when using this embedding syntax here in a template literal, any values you pass in, even if they're numbers, will be converted to a string anyways. So this implicitly calls toString anyways, you could say. So this is automatically treated as a string here. And now I build my description here and output this as well and reformat the code to use these two blanks here as indentation. And now we're building the description before we run the calculation. And now if I save this and I reload and I enter 5 here, we see the description of the last calculation we performed whenever we run a calculation. We don't see the full log because that would be way more complex to build, a bit beyond what we can do right now, but we see the exact calculation that was just executed that led to this new result. Now, with that, there's however more we can change about this function, because what we're doing here is we have a bit of code repetition. Now, in general, as a programmer, you want to avoid code repetition as good as you can, as much as you can. Because if you repeat code, you write too much and that takes time and you want to save time. And in addition, if you ever need to change something about that piece of code, about that logic you wrote there, chances are that you need to change it in a couple of different places. So therefore, you want to avoid repeating yourselves, so that whenever you need to change that piece of code you wrote, you only need to change it in one place instead of 10 places or something like that. So here, for example, extracting that user input value, let's say we renamed this user input constant here to USR input. Well, then I have to change it in 2 places. USR input, USR input. Of course, that's not too bad, but imagine that this would be a longer script. Would be very annoying. So it's better to then create a new constant, since I never plan on reassigning a value, which I could name user number, or better maybe entered number. And that could be this code snippet here. So where I get the user input and parse it as an integer. And now we can use entered number here because that string interpolation or embedding syntax here doesn't care whether that's a string or a number. It will convert it to a string anyways. And we can use it here. And now the advantage of this is that whenever something changes here, like the name of this constant, we only need to change it here and not in these two places. So even though I added a new line of code now, we actually did something good because we're now more flexible and we don't repeat ourselves. Well, of course, we repeat that name of the constant, but that's something we can't change. However, we make sure we don't repeat the entire logic here, even though, of course, that's not too much logic here, but you could have a more complex calculation and you would therefore even save more repetition. You could also take it one step further and add a brand new function. Get user input, for example. Again, I named this function like this because I want to describe what the function does. And this is a function which should actually give me the user input as a number. So we could also name it get user input number or get user number input if you want to be very clear. But in the end, you want to give a clear idea of what this function does. Well, and in there, I want to return this logic here, where I get that user input and parse it as an integer. So that here, I can just call get user number input as a function. So here I now call that manually instead of adding it to an event listener, because whenever this function runs, I want to run this function as well, which I now use to outsource this logic. That's especially great, of course, if you have more code here, multiple lines of logic, for example, that you want to share. You can then all put it into a function and call that function in any place in your code where you want to execute it. Right now, that's only one place, but that will soon change because we got more than one button here. So let's work on the other buttons now. So let's make sure we can also press the other buttons. And for that, the thing we can do is we can add more functions. We can add another function which could be called subtract, because that's what it should do. We can add another function which should in the end multiply values, and a fourth function for this, which is called divide, which does just that. Now we have all these functions, which of course are empty right now. There's nothing in the function body, but they are defined. And now let's add logic. Now the logic is generally the same as in the add function. So I'll copy that and adjust it. I want to get the entered number. And here, by the way, I can reuse that constant name because, as you learned, this constant or any variable or constant which you define inside of a function belongs to this single function, and therefore you can use the same name in another function because these two are totally detached from each other. This name is now not reused because it's not available outside of the function anyways, hence we can use it in multiple functions. So here I'm also getting the user input. Then here my description, of course, is different. I want to have a minus here, and the calculation also is different. I want to have my current result, which is calculated with a minus instead of a plus. Now you see, there's still some code repetition we have here, still some code we needed to copy. There are some pieces of code we can't avoid copying or we can't avoid reusing, like here getting access to the number input. We don't necessarily need to store this in a brand new constant. We could use it directly in the places where we need that entered number, like here. But I find it a bit easier to read if we store it in a new constant. But for generating this log text and outputting this, this is actually something we can put into a function to share and reuse the code instead of copying it. So I can add a new function up here. And again, it's just my pattern that I like to use, that I define functions before I use them. So if I use a function down there, I define it above, but that's up to you. The order does not matter, as you learned. So here I'll add a new function, name it create and write log or something like this, which should write that output, or therefore create and write output maybe. And now this function will need 3 operators to work the way I want it to work. I'm interested in the operator that was used in that function, and you can name this however you want. This should be some text which contains the plus, minus, or so on. Not the real operator which we could use because you can't pass an operator as an argument, but we can pass a text which contains the operator so that we can output it. Then I need the result before calculation and the calculation number, let's say, so the number which was used in the calculation. And then I can grab this calc description and create it here. Now the operator is also dynamic, so I'll also embed this and use my operator. And I have my result before calculation and the calc number. These are the three pieces which I combine together into one text. So that's text here. It's not a mathematical equation which is executed by JavaScript. It's just some output text which I'm generating here. And thereafter, I'll call output result here. I can refer to the current result because that's a global variable which gets changed. And my calc description, well, that's this constant. And now the idea is that here, I can actually run create and write output. The operator here was the plus, and I need that to build that string correctly, which describes the operation which was performed. The result before calc, which is my second parameter that is expected, and the order does matter, of course. So my second parameter here is the result before we ran this calculation. So here, that's current result before we ran it. To store this, I can add a new constant, initial result maybe, which is current result before we change it. Now, since we copy that value, initial result won't change if we then run this line. That's what I also explained earlier. So now we can pass initial result here. And the calc number, of course, is the entered number here. So now we can use that also down there and get rid of that line with output result and where we build the calc description. And here instead just forward that minus. And yes, we need to copy that initial result code. So still some copied code, but the logic of building that string and of outputting it in our web page, that is outsourced into a new function. And all that refactoring, as this process is called, where we move code around and try to write it in a more elegant way, is totally optional. I just want to get you used to it because it is something you will need in your life, in your day as a programmer, as a developer. You want to write elegant code where you don't repeat yourself and where you then try to split your logic. There rarely is a single right or wrong way of doing it, but getting started with it and thinking about it is always something you should do. So now with that, let's actually copy that logic into multiply. And there we need the star operator. And here in the calculation, of course, also the asterisk here to multiply this. And for dividing, here we need the slash, which is the division operator, and also output this here in our log. And now with that, if we save all of that, we just need to register the event listeners for these buttons. So just as we have an add button in the vendor file, we got a subtract, multiply, and divide button, so we can use these as well. So here I'll add subtract button, and then just copy this code here, but of course point at the subtract function here, and then repeat that, but of course now use the multiply and the divide button here. So multiply and divide button and point at multiply and at divide. Now with that, if we save that and we reload this page, if I add 5 with the plus, 0 plus 5, now enter 3 and then click minus, 5 minus 3, and the calculator now just works such that you need to enter the value and then press the button where you want to use that value with the previous result. That's how this calculator works. That's why it's the unconventional calculator. So now let's add 10 and star. So we had 2, so now it should be 2 times 10, and that's the case. And finally divide by 4 maybe, and we get 5. So this all works. Now we connected a couple of buttons to our functions, and we also had a first look at code refactoring and code reusage, an art which you will master as you work as a developer, and where you shouldn't worry if you're not totally sure how to split your code yet, that is something that comes with experience and something you will also do a lot throughout this course. So by the end of the course, you'll already feel way more confident about that than you probably do right now. Now, we wrote some code already. A feature which you can also use in JavaScript and many other programming languages are comments. You can add comments to your code to make it more understandable to fellow developers or to yourself if you're coming back to your code after a couple of months of break or something like that. Now, a comment in JavaScript can be added in two ways. You can add it here, like you add regular code, by adding 2 forward slashes. This is a comment now. This means that this is there for people to read, but it has no effect on your code. If you reload, you don't see an error or anything like that. It's not executed as code. Instead, this is just there to comment your code, to make it more understandable. If you have a longer comment to write, which should be split across multiple lines, you can of course add another line of comments here with 2 other forward slashes. But you can also add a block comment by adding a forward slash and then a star. And now you see everything is green down there because now everything after that is treated as a comment. So this is also a comment, and this is. And now you have to close the comment with a star and another forward slash. So the opposite combination we had here to open it. So now this allows you to write a longer comment across multiple lines without starting every line with 2 forward slashes. Now, how would you use comments in your code? You shouldn't comment the obvious. So if you comment, this is a function that extracts the user input from the input field, that's not the best comment. Because for one, you don't want to write long text. You don't want to write essays here. Instead, you want to write short, to-the-point comments that add some extra context or understanding that isn't obvious from looking at the code. So if I look at this code, it's pretty obvious at what it does. We could just add something like gets input from input field. Why is that useful? Because it adds this extra context that this is coming from an input field, because it might not be obvious by looking at the code that user input refers to an input field. So that could be something we could add to make understanding that code a bit easier and simply save the developer who's looking at the code the time to kind of find out what user input is referring to. Here we could add something like generates and writes calculation log. Again, this might not really be necessary because that's quite easy to see if you look at this, but if you have a first quick look at this, it could look daunting, and then this makes it clear that this is in the end just a helper function that outputs some information and generates that information as well. You can also add a comment in line, so after some code, like here. We could say from vendor file to make it clear that this function is not defined somewhere in this file, but lives in the vendor file. Otherwise, this might not be obvious. And again, if someone wants to follow our code or understand it, this could help with understanding it. So adding such a short inline comment also sometimes can be useful. In general, you want to comment your code, especially if you share it with others, but you don't want to overdo it. Don't add redundant information. Don't write too long comments because then people will not read them at all and they actually get less out of them than if there were no comments at all. And you don't want to comment the obvious. Instead, provide some extra context, extra information that can help understand your code faster, or briefly share your thoughts regarding the code you wrote here. That's something you could add with comments. We got quite a nice application going here, at least for the basics into which we're diving. Now I want to dig deeper into some of the core JavaScript features you gotta know because you will need them in many of the projects or the applications you're going to create with JavaScript. And one important feature, if you want to call it like this, is a special set of operators, which you can also use in your JavaScript code. Now, we already saw the assign operator, the plus, the minus, The multiplication and the division operator, we use those. Now there are a couple of shortcut operators, if you want to call them like that. For example here, what we're doing, and not just for adding, but also for subtracting and so on, what we're doing is always we're assigning a new value to current result, and that new value is based on the current or the old value of current result, plus or minus and so on, a number. Now, if you have a calculation like this, which is quite common, there is a shortcut. You can absolutely write it like this, but if you assign the result to the same variable you're using on the right side of the equal sign, you can omit that variable there on the right side, omit the operator, and instead write plus equal. So instead of a single equal sign, use plus equal. And that's exactly the same as having, in this case here, current result equal to current result plus. So you can remove that from the right side and add a plus here. And as you will see, if I now save this and I reload this, if I enter a 5 here and I click plus, that still works as before. So that did not change, that still works, but now we have a shorter code snippet here. We have less code which we have to write. Now the same is available for all the other operators. So instead of this code here with the minus, we can also write minus equal, and the same for the multiplication and division. So we can take this, multiply this here, and also remove that division code here and use this shortcut. And with that, if we save that, you'll see that now as I reload this, we can add, we can subtract, we can multiply, and we can also divide. This all works now with this shorter code thanks to these shortcuts. Now there also are other shortcuts or other shorthand operators, as they're also sometimes called. If you have, let's say, the case that you want to set a new value to a variable, let's say to current result, and that is the current value plus 1. So exactly plus 1, which we of course don't need here, but imagine we had that case. Then instead of writing this, you can also write current result plus plus. The same is available for minus. You can write current result minus minus. It's not available for multiplication or division, because what would that be? Multiply the number with 1? Well, that's the same number, and the same for division, right? But adding 1 or subtracting 1, that makes sense. And with this increment or decrement operator, as it's called, that is possible in a very short way. So if we do that here, and I comment out this line for the moment, this, by the way, is a common pattern that you use comments to temporarily remove some code, which you then can re-add later. But since comments are ignored, you can kind of temporarily remove code by commenting it out, as it's called. So if we do that, and we therefore only reduce current result by 1, if we click add, you will see that now if I don't enter anything here, because I'm not using the value anyways right now, if I add a plus, you have a result of minus 1. We can ignore this NaN thing for now. Here, the result is the thing that matters. So this gets lower and lower, always by 1, each time I click the plus button, because we're decrementing this here. A little side note, you could also write minus minus or plus plus in front of the variable, and it will actually have a small impact or a small difference. Not if you just use it like this to change the value, but if you're interested in the return type of this operation, if you add plus plus in front of this, it will actually edit the current result by adding 1, just as it does if you add it thereafter. If you have plus plus or minus minus in front of this variable, then this operation returns the edited value. If you have it after the variable, well then this returns the value of the variable before it was changed. Now here we're not using the return value, but if we would alert that return value, it still changes current result always in the same way by adding 1, but this operation returns a new value which you can or cannot use, depending on whether you want to use it. So here, for example, I'm using it by outputting it with the alert, and if we do that, and I reload here, you see I get 1 here, so I get the result after the change. If I add the pluses at the end here, and I repeat here, save this and reload, then I get it before the change. So this plus plus and minus minus operator returns something. It returns the value before or after the change, depending on where you add the pluses and minuses. Again, in many cases that doesn't matter because the variable itself is always edited in the same way. It just makes a difference regarding the value which is returned. Now, of course, here I'm not interested in incrementing this, so I'll just remove that line and comment this back in. By the way, in case you're wondering how I did this so quickly, I used a shortcut here in my IDE. Under Edit, you can use toggle line comment to, well, add or remove a comment to quickly comment code in or out. So these are some additional operators which I recommend that you keep in mind, and that therefore completes our list of operators which we are aware of for now with these shorthand operators and the increment and decrement operator. Those extra operators which you have are good to know because sometimes you can save some extra code by using these shorthands, these abbreviations. Even more important than that, however, are other data types you can work with. We learned about numbers, where you have numbers with or without decimal places. Numbers without decimal places are also called integers. Numbers with decimal places are also called floats. Besides numbers and text, or strings as it's called, you also got other core data types which you have to know when working with JavaScript. For example, there are booleans. Now, booleans are a bit strange and a bit hard to understand right now because they really shine once we learn about control structures, if statements, which we'll do in a separate module soon. Booleans are effectively values which have one of two possible values, true or false. So where you can, as a number, have any number, or as a string, have any combination of characters, Booleans are exactly one of two values, true or false. Now, you might wonder when you need such a restricted data type. And the answer is quite often, because quite often in code, you have some condition, like is the user currently logged in, which is either true or false. And then you want to run different code based on that condition maybe. And that's what I meant. Booleans shine if you have conditional code. And we haven't really learned about this yet, but we will learn about this in a whole module as it's such a core feature. So already keep Booleans in mind. We'll dive deeper into them a bit later, and then very deeply though. More important, and something we will see right away, are objects. Objects are an extremely important type in JavaScript, maybe the most important type if you would have to choose one. Of course, you need all of them, but objects are really important. Objects allow you to group data, you could say. Something like this. Now you create an object with curly braces, and of course we already saw curly braces when we wrote a function, and that of course was not an object, that was the function body. But without the function keyword and so on, in the place where you could also use a number or a text, you can create an object by adding curly braces, and then you have key value pairs in there. Now, as I said, you use it for grouping or relating data. Let's say you have a little program where you work with persons, where you have user data that you kind of need in your JavaScript code. Now, each user might have a name and an age. Of course, you could have standalone separated variables for that, but having an object makes it much easier to understand that this data kind of belongs together, that it's related, that you use it as one piece of information, if you will. And therefore, objects are really powerful. You can also do way more with them than just group data, and we will do way more with them throughout the course. But the data grouping functionality on its own is already pretty amazing and very important. Now, and speaking of kind of organized or grouped data, another core data type are arrays. Now, arrays are created like this with the square brackets here, also in the same place where you would create numbers or text or whatever you need. And an array is simply a list of data. So arrays are always great if you need to store a list of data, let's say a list of transactions, a list of maybe calculations in our calculator. And you can store any data in there. It can be an array of integers, so of numbers without decimal places, like in this example, but it could be an array of text, an array of floats, an array of objects, even an array of arrays is possible, and you can also mix data in there. You can have an array that has numbers and text elements and so on. Elements in an array are separated by commas, as are the key value pairs in objects. But I'd say it makes way more sense to understand and explore these objects and arrays by simply working with them. So let's do that in the scope of our project. How could we introduce arrays and objects here? Well, let's say we want to log every operation we do. So when we add, when we subtract, when we multiply, we kind of want to log this. We want to store this in an internal log, which we theoretically could send to a server or anything like that. In Node.js, we could write it to a file. In the browser, we can't because we don't have access to the file system there for security reasons. But we might want to keep track of that, right? Because we want to store it on our own analytics server, for example. Now, in such a case, we want to keep track of a list of operations because we're not just interested in the first click on the add button, but we want to store every click on every button, and therefore we need to have a list of data that gets bigger and bigger over time. For that, we can add a new global variable here, and I will create it here with the let keyword and name it log entries. The name is totally up to you, of course. Again, it should be a name that kind of gives an idea of which kind of data you're going to store. And it's a plural name here because I'll have multiple elements in there, because it should be such an, well, array, as I mentioned. Now you create an array by adding square brackets, and it can either be an empty array or of course an array with some initial data, and there each element is separated from the other elements by a comma. Typically you also add a white space to improve readability, but that's not required. The comma, however, is required. Now here I want to have an empty array though, because initially we have no log entries and therefore we can create it just like this. Now if we want to add a log entry, let's say when we click the add button here, we could say we go down there and now we want to edit this array and add a new entry. Now how can we do that? Well, we can refer to log entries, and now previously we always assigned a new value by setting this equal to a new value. Now of course we can set it equal to a new value here as well, and here the new value would be a new array because I want to overwrite the existing empty array, and therefore of course we could also leave this uninitialized, with a new array which now includes, let's say, the entered number, right? So now we set this to a new array, a new list of data with one element, and that one element is this entered number which we have. Now that's one way of editing an array. We basically overwrite the array stored in the variable with a brand new array, and sometimes that's just what you need, but sometimes you also want to edit the existing one. And for that, let's reinitialize this to an empty array up there. Let's say we want to add a new element to this existing array. For that, we can reach out to this array and not assign a new value with the equal sign, but instead use a dot to use a function that belongs to the array, so to say. And there's a specific function built into JavaScript, and that's the push function. Now actually arrays have way more than just a push function, and I have a whole module dedicated to arrays where we dive way deeper into them. For now, let's focus on the push function. The push function does what the name implies. It pushes a new element onto this array. So it adds a new element to the list. And there we could say that should be the entered number. Now it would be kind of neat to see that array. And for now we can do something which you will often do during development. You can add console log here, and that's a built-in functionality built into JavaScript, a built-in command which the browser understands, which allows you to output something into that development console, into the console which you see in the developer tools, where we previously saw some errors. Now here we're not outputting an error, but an information log message. And here we can, for example, log the log entries, so the value that's currently in that variable. which should be that array with one extra element if we run this for the first time. And after the second click, it should have 2 elements because we always push a new one. Let's see. Let's save that. Open the developer tools in your browser and go to the console there. Reload the page. And now enter any number you want and click on the plus. And of course you see the result down there, but more interesting than that, you see this thing on the right here. That is your array. And if I add another value, so if I click the plus again, you see now, this is the new log. This now is a new array, or the old array with an extra element to be precise. You see we have 2 elements in there separated by commas, in this case 2 numbers, but again you could store any data in the array, and therefore that's what we have in there. And this is a great way of keeping track of multiple items, multiple pieces of data that are kind of belonging together and that should be managed as a list of data. Now, if you want to read from the array, in the sense of not logging it entirely, but let's say you want to extract the first element that's in there, so the 5 in this case, well then you can also do that. If you want to access a specific element in the array, you do this by adding square brackets after the variable name if you access the variable. So in a place where you want to get or read the variable, you can also add square brackets thereafter. And now in there, you add the index, so the position, so to say, of the element you want to extract. Now you could think that you add 1 here if you want to read the first value, but this will actually not work. Because that's just something you have to know, but thankfully it's the case in pretty much all programming languages, or in most programming languages. Arrays are 0-based, or their index is 0-based, which means the first element in an array has an index of 0. So if you want to access specifically the first element, you want to retrieve that to work with it, then you do this with this square bracket notation and then with index 0. Index 1 would refer to the second element, index 2 to the third, well, and so on, and index 0 therefore to the first one. That's just how it works in many programming languages. So now what we should see when we log this is that we don't log the entire array, but a single value of the array, to be precise, always the first element in the array. So if I now reload this and now I add, let's say 6 here, you see I log 6, not as an array, so without the square brackets, but just a number, because that's what we're retrieving. And retrieving, by the way, does not mean that we destroy the array. It's still there, it's still managed in memory. I'm just reading a single value from there, because that's also something you need quite often in programming, that you have a list of data, but then for a specific operation, you want to work with one specific entry of that list. And again, as so often, we'll of course also see examples for that throughout the course. So that's how you can add a new element to an array. By the way, if you would try to read the second element, so the one with index 1 here, we would actually get an error here in this code, because when I reload this, when I add a new element here, you see I now get undefined, so not an error technically, but also not the value we expected. Because of course this already fires for the first element we added, so when I clicked the button for the first time, and there we simply have no second element in the array yet, because we only added 1 value, so we pushed 1 value into the array, so there only is 1 value in there, and as you learned, that 1 value has the index of 0. Only after the second button click, we have 2 values in there, and then we can retrieve a value with index 1, which is the second element. So now if I add another element here, now this gets logged. And if I add a third one, I of course still get 11 logged here, because I still extract the second element, and that's still the element we added on the second click. So that's arrays. We can manage lists of data with them. There's way more we can do with them than just push and access single elements. But again, that's also something we'll gradually learn throughout the course, because we also need some other things, some other pieces of knowledge before we can fully unleash their power. They're already quite nice like this, though, to manage lists of data. So that's arrays. What about objects? As I mentioned, objects are great for grouping data together. And you create objects with the curly braces here, and then you can have multiple key value pairs. separated by commas in them. So let's create an object. Let's say we don't just want to add the number which we added to our log, but a more detailed log information package, if you will. Because the number alone, of course, doesn't tell us much. It would be interesting to log the result before we added the number, the operation itself, so that we can add items to the log, not just here, but on all these functions, and we can then just attach the information, whether that was an addition or a subtraction operation. And therefore, we need a more complex piece of data that we manage in the list. This is a great scenario for objects, because now we need to manage multiple pieces of data that are kind of related. And these pieces of data then, in turn, are managed as a list of these pieces of data, because we have multiple such actions. So here we could add a new constant, let's say, because I never plan on editing this, which I'll name log entry, and this should hold such an object, which you, as you learned, create by adding opening and closing curly braces. Now, of course, we also use curly braces here for creating the function, but that's different. Here, we used it after the function keyword, after the name of the function, and the list of parameters. This is a pattern JavaScript detects, which tells it, well, these curly braces should now hold the function body. On the other end here, we have no function keyword and nothing like that. Therefore, this tells JavaScript, since it's on the right side of an equal sign, where you always define the values for something, for a variable or for whatever you're working with, this tells JavaScript, okay, you want to create an object. Now, you can create an object like this, an empty object, but that's not too useful, arguably. Now, what you can do instead, of course, is you can add key value pairs. So pairs of identifiers and values which you store in these identifiers. Now, often you will write an object across multiple lines. That's not required. You can do it all in one line just for readability's sake. Often you split it across multiple lines, and then you can also, of course, indent to make it more readable. And here you could, for example, add let's say operation key. The key names are totally up to you. You could name this op or operation or whatever you want, and then separated with a colon, you add the value. Now, values can be anything. Can be strings, numbers, arrays, or other objects. You can also have objects in objects. So here as an operation, I'll store a string which says add. So this is kind of my identifier, you could say, that when we see that log entry later in the output, we see, okay, that was an operation where we added two numbers. And of course, I then also want to store these two numbers. So I have my, let's say, number 1, or my previous result, so the result before the operation. You can, again, use any key name you want here. And then again, separated with a colon, the value. Here, the value, of course, should be a number, and it should be my initial result, to be precise, because that is my result before we performed this operation and we added the number. Now, we also, of course, need the value which we added. So we could name this number or operand, so kind of the value we added to the previous result. I'll name it number. And here again, separated by a colon, we now set a value to this identifier. And here, that would be my entered number, because that is the number I added to the previous result. And maybe we also want to add the result after the operation here in our log entry. So that could be the result or new result or whatever you want to name it. And here, I would simply use current result, because we changed current result here, which means 2 lines after that, it's still that changed current result, and therefore I want to add it here to my log entry. Now it's the log entry which I push here onto the log entries array, so that log entry object. And then here I want to log the entire array to my console. If we do this and I reformat my code to use 2 blanks here, 2 white spaces for indentation, if we do that and I now reload, let me again enter any number here, click plus, and now you see here we have an array, and this is just shortened in the developer tools. If I click this arrow, it's expanded. An array with index 1, so with the first element at this index being an object, as you can see, and if we expand this, we see the full object. We see in that object we have a number key with a value of 66. the operation key with the value of add, which is a string, here logged with double quotes because that does not reflect the quotes we used necessarily. Both are available interchangeably, and the developer tools here simply use double quotes. The previous result, and which was 0, and the new result after the operation. And if I add another element here, I get a new array. If we expand this, we see that new element. And if I expand this, we see our second operation where the number was 2, which is correct. It was still an add operation. Before we had a result of 66, and now we added 68. So this is how we can create and use objects. Now, before we use it everywhere, let me show you how you can extract information from such an object, because that's also something you sometimes need to do. So we're adding our log entries to the log entries array, which is great. Now let's say for some reason, maybe in another part of your code, or maybe here, you need some data from your log entry. You don't need the full object, but you need the operation. And here, let's just say we want to log it. Of course, it's kind of redundant here because we know what operation we added here, but it's just so that I can show you how you can access data on objects. And you do this with a notation, which we already saw. You use the name of the object, log entry here, and then you use the dot notation. You add a dot here, and a dot tells JavaScript that on the object in front of the dot, so log entry here, you want to access one of the properties, as it's also called. So one of the data pieces that belongs to the object. And here you see my IDE already gives me this auto completion. You can also get this by pressing Control and space. And I can then access operation, for example, and by outputting log entry dot operation. If I now reload this here and I add a 5 here, you see add gets printed here, and that's just that data piece I'm accessing here with this line of code. So the dot notation allows you to access data in objects. These key value pairs here, or the keys here, are also named properties. So you access a property here with the dot notation and then the name of the property or name of the key, whatever you want to name it. And of course, it's also something we saw before. It's also what we in the end use down there when we call add event listener on our buttons. There we also use the dot notation, and then the only interesting thing is that here I'm not accessing a property which contains some data I can read, but that I actually access some function. Because you can also have functions in objects. But that's something we'll dive into in the objects module, where we dive way deeper into objects. For now, let's just think about them as groups of data, of key value pairs, where your values can be strings, numbers, arrays, other objects, and so on, where you can either hard code data like I'm doing it here, or point at variables, and then the value of the variable will be stored here as a value for this key. And that's it for now. Objects are really powerful, and we'll see them many times throughout this course. There's so much you can do with them. For now, let's just use it like this though. And let's now also make sure that we actually are able to add log entries, not just when we add two numbers, but also when we subtract and so on. So it would be nice to generate similar log entries for subtraction, multiplication, and so on. And of course, that means we can grab that code here and copy that over to subtract, use subtract here as an identifier, and that actually is all we need to adjust. But again, that means we're duplicating code here. Now we already have one thing in common in all these functions here. We call create and write output. Now why don't we create a similar function for creating our log? So I'll add a new function here where I say write to log, and this expects to get the, let's say, operation identifier or whatever you want to call it, the previous result, the operation number if you want to call it like this, so the number we used in the operation, and the new result. Now these are very long names here, and to make this easier to read, I'll now actually also split this in multiple lines, With the code formatting shortcut, my IDE actually does this automatically. You can do that without issues. JavaScript understands this. You can't write multi-line code. You have commas between your arguments here, and therefore JavaScript is able to understand where your function parameter list starts, here with the opening parentheses, and where it ends. And you can write this across multiple lines. It's not a must do, but I'd say it's a bit easier to read. So that's my write to log function, which gets all these arguments. Now in the function body, I in the end want to do what I did here. So I'll cut that code from add and add it here, create the log entry. And now, of course, all the values I use here are the values I'm getting here as parameters. So for operation, I use my operation identifier. So this argument I'm getting here. For previous result, I use previous result. So here I have the same name for the argument I'm getting as for the key I'm using in the object. You can do that, you can avoid it if you prefer. It won't clash because, of course, these are two totally different places where you use it. So here JavaScript knows that this here on the left side of the colon is an identifier in the newly created object, and it would never look for a variable of that name because you can't use a variable here. And on the right side, it knows it needs a value, so it looks for a valid value, and it could be something hard-coded, like some string you enter in place, or it could be a variable that holds a value. So here, JavaScript will look for a variable, or in this case, for a parameter, which is like a variable, and therefore it will take that variable's or that argument's value. For number, I want to use operation number, and for result, of course, new result. And now this is added, and I also log this. And now we just need to call write to log and provide all these pieces of information, so these 4 arguments. So here in add, we can call write to log like this. And now the identifier could be add. Then our previous result, and my IDE here gives me some auto-completion support to tell me which value for which parameter I now need to enter. So here for previous result, that would be the initial result variable value which I have stored here, so that this is provided to the function. For the operation number, that would be the entered number which I want to pass into the write to log function. And for the new result, that would be, well, current result at this point of time, right? Because we change it here, so 2 lines thereafter, it's still the same result, and therefore I pass this to the write to log function. And now we can copy that and call that here in subtract as well. Leave everything as it is, but change the identifier. And do the same here for multiply. So here I'll add multiply as an identifier. And of course, do the same here for the division and add divide as an identifier. And now we're reusing this write to log function to create our log object with different dynamic data which we add in, which we get as parameters in the function, which we then use to build that object, which we then add to our array, which we then log to the console. So let's give that a try. Let's save that and reload. And now deduct 5. So we have -5 here. We have an entry in the array. We see the operation was subtract. Previous result was 0. Number now is 5 or was 5. Result is -5. If I try to multiply this with 7, got a new entry in the array. This one is it. Previous result -5, number 7. We multiplied it, so the new result is -35. And now if I divide this by, let's say, 2, got a new output here. Divide, number is 2, previous result is -35, result is, therefore the new result is therefore half of that, -17.5. So that all seems to work. We're able to log that, we're able to reuse that logic, and we're able to do this basic work with our JavaScript object here. With arrays, booleans, objects, numbers, and strings, we had a look at the most important, or almost all of the most important data types you have in JavaScript. Now there are 2 additional important data types and one strange value which looks like a data type. And that would be null, undefined, and NaN. Now what's that? So these are kind of special values, though null and undefined are both values and data types. So what's the idea behind that? Undefined is the default value uninitialized variables have. So if you create a variable and you don't assign a value at the beginning with the equal sign, then this variable is undefined. We also saw undefined in the log when we tried to access an element in the array at an index where no element was created yet. Then we tried to access an element which wasn't there, and therefore we got back a value of undefined. So that's a value. It's a value that indicates that nothing's there. But at the same time, it's also a separate data type. So just like numbers and strings are a data type, undefined is also a data type actually. Now, you should never assign undefined to a value on your own, so never write equals undefined, because that's just a default value you have if something has never been assigned a value. Now, you could have cases in your code where you indeed get something where you're not sure if it's undefined or not, and later you will learn how you can check whether a value is defined or undefined, but it's already important to be aware of this type. Now, related to this, there's the null value and type. Now, it's very similar to undefined. It means that there is no data, but undefined is the default value for variables and so on, where you never assigned a new value. Null is never a default value on the other hand. Instead, you have to set something to null to use that value. And that's often used if you want to reset or clear a variable. Let's say you have some user input and you want to reset this. You could set it to an empty string, but you could also set it to null, for example, to make it clear in your program that there currently shouldn't be a value because no value has been entered or whatever. And again, this is especially useful later if we can also run some checks, some conditional checks with if statements to find out if a value is set and then do something, or if it's not set. So undefined and null are important to manage empty data, either because it never was set or because you want to set it to empty to null. They're very similar, but they're not entirely equal because of the reasons I explained. Now, there also is one other special value, and that's NaN. That stands for not a number. And technically, unlike undefined and null, which also are their own types, this is not a type. Instead, it's of type number. It's not its own type. And you can therefore use it in calculations where you work with numbers. Now, the idea behind NaN is that it's kind of like an error code if you run a calculation with something that doesn't include a number. So if you have, let's say, a multiplication with text or anything like that, then you would get not a number as a result. And if you use the not a number value in a calculation, you also get not a number as a result. So this yields not a number if you use it in calculations, and it's the result of calculations that are invalid. Now you might wonder why you would ever run an invalid calculation. Keep in mind that JavaScript allows you to write highly dynamic code. So, like in the case of our calculator here, you could have a calculator where users can enter any value, where they are maybe not forced to enter a number, and where therefore you could run a calculation with some user input, which is not a number, and then you could get such a not a number result. Again, this is most useful if you also have the abilities of comparing it or of checking it with some if statement to run some code if you get such an invalid result, but it is worth being aware of this type. Now, to quickly give you an idea of these types, let's clear that JavaScript console here, because here we also can type some JavaScript code which runs immediately, which is immediately evaluated. And here I want to show you these three types I just talked about. Let's create a variable here, username maybe, and not set this equal to anything, just like this. So we declare it, but we don't initialize it. If you now hit enter, you see undefined here, because that's the return value of this execution here. But if you now write console log username, or actually here in the console, you can just write username and it will automatically log it to the console, you see the value that's in there, and that's also undefined. Now, of course, if I now assign a value like max, and I print this, you see, well, max here. It also showed it here. So that's one thing. We got undefined if we haven't set this to a value yet. Now, if you would want to reset this, as I mentioned, you should never do this. Technically, this would work, but this is not recommended. Instead, you should set this to null now, this other special value. And if you do that and you have a look into username now, you see this indeed is null. Now for the not a number example, if you run 3 times hi here, you see the result is not a number. If you run 3 times not a number, which is also a special value written like this, you also get not a number. So these are the special types which for now you should just keep in memory somewhere, and which we'll come back to throughout the course when we'll be able to check for whether a variable has a value or not. For now, just loosely keep these values in mind. Now that we had a thorough look at these basic and very important types you can use in JavaScript, these types of data, I want to show you a little keyword, which you can use in your code here, of course, as well. And that's the type of keyword. The type of keyword lets you evaluate the type of a variable at runtime. Now we could use it here, but to quickly see the result, I'll just do it here in this console. You use it by typing type of, and then the name of the variable which you want to evaluate, or of course just the hard-coded value like this string here. So here, if I run this, you see I get back a string which contains the name of the type I used. So here it's a string with the name string in it, and indeed that is the case here, right? That is a string. Now of course we could also use our username variable which we initialized earlier, set this to max, and check type of username here, and would also get string, right? So we can also use a variable here, and you'll get the type of the value that's stored in the variable. Now we can of course also check the type of a number, and you see it is number then. It's a string which simply contains the description of the type, so in this case number, or the name of the type, so in this case number. And that's the same no matter if we use an integer as here, or a floating point number as we do here. We also can check type of true. Now we haven't really worked with true or false yet, but these are these booleans I mentioned, and hence of course it prints boolean here. We can also check the type of an array, like this. And you see here we actually get object, and that's interesting. An array is a very important feature. Very technically though, it's of type object. So there is no special array type. It's a special type of object, if you will, but the overall type is just object. So thus far we saw string, number, boolean, and now object. Now unsurprisingly, if I check the type of an object, which I create with curly braces here, I also see object being logged here. So they are of the same type. An array is just a special type of object, you could say. Now if we check undefined, we see, as I mentioned, that this has its own type, undefined. On the other hand, null is also just of type object. So it also has a type, a special type, which is not the same as undefined, but it's not type null, but instead type object. So another special kind of object, if you will. If you, on the other hand, check not a number, written like this, we see it's of type number. So this is not an object, this is not undefined, this is not its own type, this is a number instead. So type of, quite nice here to get an understanding of which kind of data you're working with. Of course, we'll see all these different types of data in action throughout this course and all the examples where we need to work with numbers, with strings, with arrays, with objects, and so much more. Now, to conclude this module, let's come back to something we actually started the module with. And that's how we import our scripts into the HTML file. I'm doing this here at the end of the body tag, at the end of the body section in the document, and I'm doing it here because our scripts rely on the HTML page being rendered. We're accessing items in the page, so to say, in the vendor file, where I establish connections to the buttons and so on, to which I then add event listeners here in the app.js file. And in order to establish these connections, we need to run the scripts after the browser parsed and rendered all the HTML code. Otherwise, the buttons to which we want to establish connections simply don't exist. So that's why I import the scripts down there. Now, this is still not entirely optimal, and let me show you why. For this, open your page here in a new incognito window here in Chrome. And I simply use this incognito window here because this allows me to rule out that what I'm about to show you gets distorted by any extensions or browser plugins. So I opened the page here in Chrome in the incognito window, and now we can again open the developer tools, which allow us to have a look behind the scenes. And there I increased them in size a little bit, and there you should go to this performance tab. You can also click these arrows here if you don't find it here. Now, what's the performance tab? The performance tab allows us to get an idea of what the browser does in detail when it renders this page. And there are many things you can do with it, but it's a great tool for understanding how the scripts are loaded, parsed, and executed, and what might be the issue here. So with the page being used here, press this record button here, and then reload the page by using a shortcut for it or using the reload button, and then stop recording this. Now you get this profile, and this might look confusing at first. I'm only interested in a short part of this timeline. Now in this topmost window, you can select a part by holding the mouse button and dragging, and I'm interested in this part where we have these little hills down there, you could say, and where you have these vertical lines. Now if you select this, it gets zoomed in here in the middle and bottommost window, and there you see which network requests were sent and what the browser did, so what it parsed, what it executed, and so on. Now what we can see relatively quickly is that we have one long-going network request which downloads the fonts. This kind of distorts everything here, so let me comment out this link here, which does load the fonts, to not have this distraction in here, so that we can focus entirely on the scripts. So comment this out in the HTML file so that this is no longer getting used, save the file thereafter, and then let's repeat it, let's clear this, press the record button, reload this page, stop recording this, zoom in here. Now we have a clearer picture of what happened. What happened is that here in the network tab, we first download the index.html file, that's the blue part, and thereafter the CSS file and the script files. Now let's go to the bottommost window. There we see what the browser did in detail. And if we zoom in here, which you can do with the mouse wheel, you see that in the end here, we receive a data. That's the downloaded HTML file. If you see, this roughly lines up here in the network tab. It's done downloading the file. That's when this receive data event is triggered, when it finished loading it. And then it starts parsing the HTML code. Now it starts parsing the HTML code, and what you can see is that pretty much at the end of that, when it's done parsing this, it sends off requests to the JavaScript files. The CSS file is sent off relatively early. If you would draw a vertical line down there, that happens early when that gets parsed, which makes sense because we request the CSS file here in the head section. But the JavaScript files get requested a bit later because we request them at the bottom of our HTML file. Now, obviously, that's not a huge file, so there's not much time difference between, but still, we request the JavaScript files only after the parsing is done, or when it's almost done entirely, because we do that at the bottom of the HTML file. So that's why we only request the files once we're almost done parsing the HTML document, as you can see with this vertical line. Now, what's the implication of that? Of course, the benefit is that the scripts only execute after parsing is done, but we also see that we start parsing, and only when we're done, we download the scripts, and only once the scripts are downloaded, way over here, of course, that's not that long if we have a look at the milliseconds, I'm only talking about a few milliseconds here, but still, only after this is done, we actually execute the scripts. These are these yellow blocks you find down there. These are the two scripts which are getting executed. The other parts are the style sheet being parsed and the styles being rendered. We can ignore that. So here we execute the scripts. Now what we effectively see is that we start executing the first script at around 930 milliseconds, and we're done parsing at around 906, 907. So there are roughly around 20 milliseconds of pause between us being done with parsing the HTML file and executing the script. Now, these are all very small numbers, which we can't even feel when we load the page, because we have small scripts and we have a small, short HTML file. But imagine that our scripts would be longer, that they would take longer to load and execute, and that we have way more HTML code that needs to be parsed. Then it's not that great that we wait for all this code to be parsed just to start loading the scripts. We certainly want to execute them after this was parsed because we rely on the parsed content, so that's fine. We don't want to execute the scripts earlier, but loading them earlier, downloading them from the server earlier, that would be a good idea. Also keep in mind that all the loading is very fast here, of course, because we're doing this all locally. We're just accessing the file here. There is no web server involved. There is no latency. So this would be slower if we were really serving this web page. And hence we have the ideal scenario here, and yet we have this unnecessary delay, and we certainly want to shrink that delay if we think about really hosting this on a web server. We don't want to start loading the scripts once everything was parsed. We want to load the scripts as early as possible and then still only execute them after everything was parsed. So we want to get the best of both worlds. Now, of course, we can grab the scripts and move them in the head section, maybe here below the style sheet. Now, if we do that, and I clear this, start recording and reload and stop, we get a better picture here. If I zoom in, here we download the HTML file, and now what we see is that we start parsing HTML. Now, we then fetch the styles and the scripts, and we pause parsing here. As you can see, we pause that. We only pick it up back here when basically downloading the scripts finished. We also executed the scripts here. Now, this looks a bit strange. It looks like we downloaded app.js for longer than it actually took because we do execute it here. So this is a bit distorted. The main takeaway here is that we start parsing HTML, then we encounter these script imports, we then download the scripts and pause parsing, therefore, this blocks parsing, and then we execute the scripts, and only thereafter we continue parsing. Now that's of course bad, and this also causes an error, because now we try to interact with the buttons on the web page without those being ready, so that's also not ideal. We download the scripts earlier, which is great, but we now also execute them too early. The solution is an extra attribute which we can add to the scripts, and that's the defer attribute. You add it like this, without a special value, just like this, to both script tags, and defer tells the browser that it should download these scripts right away, but that it should not block parsing HTML, so that it instead should continue with parsing HTML, and only execute the scripts after everything has been parsed. So it starts downloading early, but it doesn't execute the scripts right away once they finish downloading. Instead, it guarantees us that it only executes the scripts once they were downloaded and once parsing HTML finished. So if we now save this, and we go back, clear this again and create a new snapshot, reload, stop. If we now zoom in here, we see HTML file is downloaded, we start parsing it, and then here what happens is that I download all the scripts and I execute the scripts over there, the two yellow blocks here, but parsing HTML did finish before that. This is the entire HTML document being parsed. This blue block here is the style sheet. This is not HTML, and these are just some events in between these small blue blocks. So now the script downloading and execution doesn't block the HTML code from being parsed and rendered. Instead, that continues. And the only thing that does change is that we download the scripts earlier, which is great. Now again, in this scenario here, that's all a bit hard to really see because it's all so super fast because I serve it locally and we have very small files. But the general concept and the difference should be clear. And of course, this matters way more if you really serve this on a server and if you have bigger files. And you can see that all this parsing and script execution is done roughly 20 milliseconds after we started parsing the HTML document. So that is faster than what we saw previously when we started loading and then executing the scripts at the bottom of the body tag. So therefore, what you should do when working with JavaScript is you should import it like this in your head section with the defer attribute, because this ensures that it gets loaded early but executed only once parsing HTML finished. So you have the best of both worlds. Now, sometimes you also have scripts which you want to load early, but which you then also want to execute early, because maybe they don't rely on the HTML code. You don't establish a connection to it, and therefore you don't care whether parsing HTML finished or not. This can also be achieved by using the async keyword instead of the defer keyword. Async works a bit like defer. It tells the browser to start loading the scripts as early as possible, and then the browser is not blocked but instead continues parsing HTML. But the difference to defer is that with async, the script then executes right away once it was downloaded. So it does not wait for all the HTML code to be parsed. Instead, it executes as early as possible. So then parsing of HTML will be paused until it is executed, and only thereafter it will pick up again. Here, therefore, this is not the correct solution, because that could lead to the script being executed before all HTML code has been parsed. But in other scenarios where your scripts don't interact with the web page because you maybe just send some data to some background server, well, in such cases you could use async. One other important difference to be aware of is that with async, a script really executes as early as possible, so as soon as it was downloaded. The order of the script execution is therefore not guaranteed. The app.js script could execute before the vendor.js script if it is loaded earlier. With defer, on the other side, the browser guarantees the order. So even if app.js would be downloaded faster, vendor.js would still execute before app.js. So the order is guaranteed with defer, it's not with async. So async is really just a solution if you have a standalone script that doesn't rely on your HTML content. Also note that defer and async are only available if you have an external script. If you have an inline script, so a script which you write right in here in your HTML file, if you have something like this, defer and async is ignored, because what would that do? There is no file to download. This is embedded in the HTML file, so this is available once the HTML file was downloaded. So therefore, defer and async doesn't make sense here, because there is nothing that would need to be downloaded. Such scripts are always executed immediately, and therefore if those scripts which you embed here rely on the HTML code, you always have to move them to the end of the body section. But in general, it's not a good idea to have important or longer scripts here in your HTML file. You should always use external files for that, to keep your HTML file small and focused, and don't bloat it with a lot of scripts. Also important, you can't combine an inline script like this and then an import with the source attribute. If you do that, then the inline script will be ignored and just the external file will be imported. So you can't combine that. Now with that, let me remove that and turn this back to defer, because that's now our final setup. And if I now save this and I close the developer tools and I reload here, and I also comment back in my font because now I want to have it back. If I do that, you see this still works as before, but now it does so with the help of scripts that are loaded in a more efficient way, which does not make a big difference for this simple application, for this simple demo here, but which does matter, or could matter, a lot for bigger applications which you really host on a web server. This is it for this module. This was a crucial module where you learned a lot about the basics of JavaScript. You learned about variables and constants, which you create with let and const, about the differences between declaring a variable or constant with let or const, and initializing by assigning a value with the equal sign. You learned about operators like the equal sign to assign a value to a variable, or the plus and minus operator, multiplication, these shorthand operators, and also the increment and decrement operators, if you remember. You learned about functions, which allow you to define code that can execute multiple times whenever you call the function, or also, as we're doing it here, whenever you click somewhere or whenever some event occurs, for example, which is something we'll also dive way deeper into later throughout this course, because we'll work a lot with the web page and events and so on there. You learned about how to manage data in general, how to pass data into functions, how to work with parameters you receive in functions, how to write proper code, how to use the right syntax, how to work with numbers and strings, how to work with objects, and how to work with arrays, which are lists of data. You also learned how to import your scripts properly, which is of course important because you want to optimize such things as well to ship the best possible experience to your users. And with all of that, you have a solid foundation for the next chapters in this course. We're still only getting started. There's so much more we can learn, but it's super important that these basics are set. So really make sure that all these concepts are clear. Also use the additional resources you find in this section, the attached resources, the text lectures where I also clarify and summarize things, where you can also come back to if something is unclear at a later point of time or if you forget something. And with that, let's move on and dive deeper into some core features which you need in pretty much any JavaScript application you're going to build.